places of natural interest. More importantly, Victoria is an IHE young geomorphologist, and she was here in India in 2017 when she participated in the first intensive training program conducted by the International Association of Geomorphologists and European Geoscience Union, and that took place in the Indian Himalayas in 2017 in Dehradun, to be more specific. So, dear friend of mine, I will leave this space to Victoria, and she will present now. Association of Geomorphologists and European Geoscience Union, and that took place in the Indian Himalayas in 2017 in Dehradun, to be more specific. So, dear friend of mine, in Greece, I will leave this space to Victoria, and she will present now. Kapil is busy with Association of Geomorphologists and European Geoscience Union, and that took place in the Indian Himalayas in 2017 in Dehradun, to be more specific. So, dear friend of mine in Greece, I will leave this space to Victoria, and she will present now. Kapil is busy with Association of Geomorphologists and European Geoscience Union, and that took place in the Indian Himalayas in 2017 in Dehradun, to be more specific. So, dear friend of mine in Greece, I will leave this space to Victoria, and she will present now. Kapil is busy with Association of Geomorphologists and European Geoscience Union, and that took place in the Indian Himalayas in 2017 in Dehradun, to be more specific. So, dear friend of mine in Greece, I will leave this space to Victoria, and she will present now. Kapil is busy with Association of Geomorphologists and European Geoscience Union, and that took place in the Indian Himalayas in 2017 in Dehradun, to be more specific. So, dear friend of mine in Greece, I will leave this space to Victoria, and she will present now. Kapil is busy with Association of Geomorphologists and European Geoscience Union, and that took place in the Indian Himalayas in 2017 in Dehradun, to be more specific. So, dear friend of mine in Greece, I will leave this space to Victoria, and she will present now. Kapil is busy with Association of
several values, from ecological values due to the interaction between different ecosystems with different ecosystem, which gave an important ecological value to coastal areas. Then coastal areas have a high economical value due to the influence of anthropic activities. Human being settled economic activities, utilities, infrastructures along the coast, as we can see in the pictures of the La Valletta, the capital of Malta, the capital city of Malta, which, as you can see, is very anthropized, and also it is a UNESCO World Heritage Site. In fact, coastal areas may have a cultural value. In fact, they were occupied since historical, even prehistorical times by towns and villages. Starting from these premises, we can see that due to their potential economic damages, the loss of cultural heritage, and the loss of natural habitats and biodiversity, coastal areas are particularly prone to the impact of marine processes, such as waves, currents, storm, and so on. They are even enhanced by sea level rise due to the ongoing climate change. Here, a key observed and projected climate change and impacts for the main biogeographical region of Europe from the European Environmental Agency report of 2017. In the report, it is illustrated that all European regions are vulnerable to climate change, but some regions will experience more negative impacts than others. Those areas are called hotspots. And we can see that the Mediterranean regions are projected to be a climate change hotspot, as it is expected to face the highest number of adverse impacts, such as risk flooding from rising sea level and the possible increase in storm surges, as well as changes in marine ecosystem as a result of marine acidification, warming, and the expansion of oxygen-depleted dead zones. Here I've put just some news, recent news related to climate change impact in Italy here an example of the Mediterranean hurricane Apollo. This is just an example, but this is the more recent example. But I know that you can heard about many of these examples in your countries. The Medicane Apollo was particularly tough and hard because it caused the death of 3 persons and many damages. This happened just a few days ago, and so I decided to put this news in this slide and show it to you. In this context, we can see how it is important to promote the conservation of coastal areas and their adaptation to a changing climate, and which is a worldwide issue. Coastal vulnerability and risk assessment are fundamental for supporting integrated coastal management and identifying sustainable management action. But sometimes the terms vulnerability and risks are often used to describe the potential negative effects of climate change on environmental, social, and economic factors. But this concept often results conflicting interpreted by researchers and policymakers. So it is important before starting and going into the deep of the outputs and materials and methods of these researches to define a common conceptual framework. Only in recent years, in fact, a common and shared definition of risk, exposure, and vulnerability concept in climate change adaptation and disaster risk reduction has been provided by United Nations bodies, among which the IPCC. Here, a scheme of the 3 determinants of risk. Risks can be defined as the result of the dynamic interaction between climate-related hazard with the exposure and vulnerability of the affected human and ecological system to a specific hazard. This is the definition provided by the IPCC in the 6th assessment report. Thus, from the definition of risk, we can see that a methodological procedure for risk assessment required a preliminary evaluation of hazard potentially impacting on an investigated area of the exposed elements, natural and anthropic, and the related physical and social vulnerability. Later, we define hazard. According to IPCC definition, hazard is the potential occurrence of natural or human-induced physical events that may cause losses, different types of losses, loss of lives, services, ecosystem, etc. Then we go through the susceptibility. The susceptibility can be defined considering the definition of the assessment report number 4 of the IPCC, the degree to which a system is affected adversely or beneficially by climate variability or change. Susceptibility is also the risk is also linked to the exposure, the presence of people, ecosystem, environmental function, elements in general that are in places or settings that could be adversely affected. Exposure is linked also to vulnerability, which can be defined as the propensity of the element identified, the exposed element, the propensity of the exposed element to be adversely affected. The importance of risk assessment with respect and in the context of climate change was mentioned for one of the first time in Europe by the European Flood Directive. It requires member states to identify the river basin and coastal areas at risk of flooding, even considering climate change impacts. And at European level, again, we have the strategy and adaptation to climate change. In fact, at Action 4, the Action 4 is addressed to the regional and local level analysis of risk assessment. At United Nations level, worthy of notice and fundamentally was the Sendai framework, which recognized the risk assessment as an important preliminary action for risk reduction and increasing resilience. Finally, the 2030 Agenda for Sustainable Development mentioned at Goal 13 the importance to take urgent action to combat climate change and its impact. This is the conceptual framework and the policy framework related to climate change. The climate change, one of the topical issues, prominent issues related to climate change is sea level rise. Here in the pictures, the projected sea level rise under different shared socioeconomic pathways scenarios according to the last IPCC report, the sixth. As you can see, the sea level projection illustrates that sea level is going to rise. For the worst scenarios, it will rise, it probably likely will rise about 150, 1.5 meters, within the 2150. But what are the impacts of sea level rise? Sea level rise may cause wetland loss, coastal erosion, saltwater intrusion into water coastal storage, coastal flooding, and last, permanent inundation. Before starting to talk about our research, this was just an introduction, I would like to mention the project background of our researches. The study presented here was possible thanks to a series of projects financed by the European Major Arthur Agreement of the Council of Europe. We started in 2016-17 with a project focused on the developing of geomorphological mapping skill and dataset in anticipation of subsequent susceptibility, vulnerability, hazard, and risk mapping. Following the project, another one was focused on the production of hazard and susceptibility mapping and to the identification of mapping of coastal portability. The current project is addressed to the long-term objective of risk assessment and mapping. We can see that the global objective of this project, this is the aim that guides our work, is to provide the national authorities responsible for planning civil protection with a well-defined methodology for mapping of coastal hazard and for risk mapping through a stepped approach that crosses hazard, vulnerability, and risk assessment. Just an overview about the methodology, which I'm going to illustrate. The step 0 is constituted by the identification of coastal features and hazards of a certain area by territorial data analysis, geomorphological field surveys. In our step, the main outputs of the step 0 in our project was the development of geomorphological map, land cover map, and coastal geomorphotype map. Step 1 was the vulnerability assessment through the recognition of the exposed elements in hazard-prone zones, the implementation of exposure maps, and through data overlay to get the final overall vulnerability map. The step 2 was focused on susceptibility assessment. The topographic setting was considered, and then future local scenarios were considered to obtain the sea level rise susceptibility maps. The final step was the assessment of sea level rise risk by the overlapping or overlaying of the overall vulnerability map and the sea level rise susceptibility map to obtain the sea level rise risk maps. This is our study area, considered a pilot area, not all the Maltese archipelago, but we decided to focus on a pilot study area which is highlighted by the circle in red. located in the northwestern part of the Gozo Island. As mentioned by the title, the Gozo Island is in the central Mediterranean Sea. It is part of the Maltese archipelago. It is very close to Sicily, only 90 kilometers from Sicily and 210 kilometers from the Tunisia. The area, as you can see in the pictures, is characterized by two fault systems, which gives the first system gives the characteristic graben and horst topography of the archipelago, and the other system is parallel to the Pantelleria rift system. I am talking about the structural framework of the study area because even if the area is the Maltese archipelago is surrounded by many active structures, there are many studies and many evidence that illustrate that the area is tectonically stable since the Quaternary. So the archipelago can be considered an open-air laboratory for the study of sea level rise impact, because the sea level rise impact is not contaminated by structural signals. Just a brief geological setting, because it will be fundamental in order to understand the other research steps. Here we can see better with the underline in the pink color the study area. The geological setting is constituted mainly by geological formation, sedimentary geological formation, ranging from the late Oligocene to the late Miocene. The oldest geological formation is the lower coralline limestone, constituted by biomicrite, biosparite, hard. And it is not very frequent to find outcrops of lower coralline limestone in the Gozo Island, and mainly it forms steep cliffs. Then we have the Globigerine limestone formation, softer with respect to the lower coralline limestone formation, constituted by planktonic foraminiferal limestones. And then we have the blue clay formation. Blue clay formation constituted by soft marls, sands, and clays, which forms gentle slopes and is frequently outcropping. The succession is ended with the upper coralline limestone, the youngest of these geological formation. It is quite hard limestone, which forms the characteristic plateaus of the Gozo Island as well as the entire Maltese archipelago. The geological formations are almost subhorizontal, with just a small tilting of 5 degrees toward northwest. The landscape is largely controlled by the different resistance to erosion of the 4 main lithostratigraphic units. The upper coralline limestone, in fact, forms vertical cliffs of varying heights. Blue clay formation constitutes gentle slopes locally reaching the sea, while Globigerine limestone formation forms flatland areas along the coast. And finally, the lower coralline limestone formation forms built-up sloping coast with few subvertical cliffs. Going ahead with the steps of the research, the first the step 0 of our research was aimed to provide the first detailed geomorphological map of the northeastern coast of Gozo, considered, as I already mentioned, as a pilot study area, including also its continental shelves. In fact, our study integrated the analysis of terrestrial and marine geophysical data to provide an integrated terrestrial and marine overview on landforms, geomorphological landforms. This was a preliminary step for subsequent susceptibility, vulnerability, and risk mapping. In fact, we believe that in In order to produce an effective, useful tool for susceptibility, vulnerability, and risk mapping, it is important to constrain the geomorphological framework considered in this research as zero step. Materials and methods related to the building up of the geomorphological map of the investigative structure of coast consisted in geomorphological field surveys focused on identification of processes and landforms, coastal geomorphotypes, and land cover types. After geomorphological field surveys, analysis and interpretation of aerial photograph and the digital elevation model was carried out. Again, not only we focus on the interpretation of aerial photograph and DEM of the terrestrial realm, but also we consider the bathymetric data. In particular, we used the 10-meter resolutive multi-beam bathymetry and a high-resolution 1-meter bathymetric LiDAR. Of course, the analysis and interpretation of remote sense data was ground-truthing with the geomorphological field surveys several times. For this reason, I've put the arrows with the double direction. And then all these data were stored in a geographic information system, fundamental for the production of maps. And finally, we produced the geomorphological map. The geomorphological map was accompanied by land cover map and map of coastal geomorphotypes. Just a brief parenthesis about the novelty and importance of integration of terrestrial and submarine data. These slides are taken from an article by Prampolini et al. In 2020, 7 good reasons for integrating terrestrial and marine spatial dataset in changing environments. In fact, integrated research merging the terrestrial and submarine data can contribute into several fields of research fields in coastal areas. For example, in geomorphological mapping, and here we will see an application of this. Coastal landscape evolution for a deeper understanding of late quaternary changes of the coastal landscapes. In geoarchaeology for an integrated and new approach in the study of geoarchaeological remains. And in geoheritage and geodiversity for a more comprehensive recognition of geoheritage sites and elements. In geohazard and also in marine landscape ecology to support other disciplines involving generating key data for sustainable management and marine resources. And finally, in coastal planning and management to produce more suitable objective in planning and management of coastal areas. Also in the framework of integrated coastal zone management. Regarding the outputs of our research, we were able to identify several coastal features. They were identified based on the classification provided in Furlani et al. In 2014 and Biolchi et al. In 2016. In particular, we identified built-up coasts, which are intensely urbanized coasts. The landscape there is significantly modified by urban activities. An example is shown in the picture A. This is Gozo Island, and in particular, this is the Marsalforn Bay, a toponym that will be mentioned hereafter. And then we have cliffs. Vertical cliffs are constituted by steep slopes descending to the sea with a concave-shaped ramp. And then we have sloping coasts, which are low-lying rocky coasts with a slope ranging between 5 and 45 degrees. Then we mapped plunging cliffs, which can be understood as vertical or subvertical cliffs descending into the considerable depth far below low tide level without any development of shore platforms or ramps. And then we have screes, which are very peculiar in Gozo Island and in general in the Maltese archipelago. In fact, they are extensive slope failure deposits that cover a cliff or a sloping coast. They are called rdum in Maltese. And we have also shore platforms, as we can see in the picture number F, which are horizontal or subhorizontal rock surface produced along the shore by the action of marine processes or by the retreating of cliffs. And finally, we have pocket beaches, which are sand and gravel deposits located in an inner position of bays and inlets. In figure G, we can find an example from, again, the island of Gozo, of course, and this is the Ramla Bay pocket beach, which is very, very important from a touristic point of view because it's one of the biggest in the Maltese archipelago, and also from a natural point of view because it is backed by sand dunes, which constitute an important environment. This is the output of the recognition on coastal geomorphotypes, which accompany the main geomorphological map. In the graph, in the picture, in the diagram on the left side, we can see the percentage of the occurrence of coastal geomorphotypes. The coast, admittedly, the investigated stretch of coast is not characterized by low-lying coast. The sloping coasts are the 21%, but it is a quite good percentage, high percentage, yes. And also, built-up coast, intensively urbanized, constitute the almost the 10% of the area. The geomorphological studies concern also fluvial and slope landforms due to running water. In the area, there is not a proper permanent hydrography. This is due to the small amount of annual rainfall and the presence of discontinuity in rock masses. But the area can be affected by flooding. In fact, in the area, the main hydrographic network is constituted by V-shaped valleys as well as flat bottom valleys, which are locally occupied and temporarily occupied by stream bed. In the pictures, we can see an example of what I am saying. For example, in picture B, we can see the Ramla Vied. Vied is the name, Maltese name to indicate temporary stream bed. Ramla Vied is almost like this, as shown in picture B, for all the year. But in occasion of intense rainy period, after intense rainy period in particular, it can be like picture A and picture C are showing. And in picture D, we can see Ramla Bay during a flash flood event. Those flash flooding, those temporary stream bed flooding phenomena are exacerbated by climate changes. I say that the geomorphological maps was saw the integration between the fluvial and slope landforms in a submarine environment. In fact, here in the picture, major Vied valleys continue below the sea level. They represent the channels that are carved in present-day seafloor, and they are interpreted as relict fluvial valley. They are very important from a paleogeographical point of view. In fact, relict fluvial valleys witness the existence of a pilot drainage pattern produced by fluvial processes active in a more humid period, characterized also by sea level low stands. And here Of course, the main geological formation of crop in the area are limestones, and we have karst landforms. They are mainly small-scale karstic features represented by solution pools, grooves, and furrows. Finally, we mapped gravity-induced slope landforms, which represent hazardous processes. For example, we mapped block slide, as you can see in the picture number A, earth flow and block slide and rock falls in correspondence just below the upper coralline limestone scarps. The block slides and earth flow slides run out often continue and locally continue below the sea level, reaching minus 20 meters in depth. According to the evidence of landslide dating carried out along the northwest coast of Malta, it is likely that those gravity-induced slope phenomena occurred in subaerial environment during sea level or low stand phases, and they were successively drawn during post-glacial marine transgression. As I already said, the geomorphological map was accompanied by the land cover map. The main land cover of the study area was represented by agricultural areas. Agricultural areas located in correspondence of sloping topography are often terraced using barriers made of the limestones, local limestone rocks. As you can see in the first picture, this is reported an example of terraced slopes. Even if most of the area is as an agricultural vocation, this investigative stretch of coast has some anthropic elements which can be potentially exposed to hazard, marine-related hazard and gravity-induced hazards, such as the Marsalforn Bay, which constitutes an important and attractive tourist sites with a lot of tourist utilities and so on. The area also contains cultural heritage site represented by a Roman villa. In the last pictures below, we can see the remnants of this Roman villa. But there are also other cultural sites related to the medieval period. This is the main map, as you can see, accompanied by the coastal geomorphotypes and land cover map. The map was published in a peer-reviewed journal with the title Geomorphology of the Northeastern Coast of Gozo. Let's go through the method. We have defined the geomorphological framework through detailed geomorphological investigations integrated with the analysis of marine geophysical data, which allow the characterization of the main coastal features and identification of areas susceptible to coastal hazards along the northeastern coast of the Gozo Island. As we have seen, Gozo features a high economic value and derive mainly from tourism activities and natural protected areas that altogether make coastal vulnerability a major concern. Here is proposed an index-based method, an index-based approach for the evaluation of the coastal vulnerability, which draws on the methodologies proposed in the framework of the RISKIT project. Here there is the reference of the RISKIT project. The vulnerability assessment was carried out by identifying exposed element in hazard-prone zones, by developing exposure maps, and then by data overlay to obtain the overall vulnerability map, following again the RISKIT methodology. In detail, the vulnerability analysis was based on the conceptual interpretation of overall vulnerability to marine-related and gravity-induced processes such as coastal erosion, landslide, and sea level rise, defined as the combination of two components, which are physical vulnerability and social vulnerability. The two components were evaluated using a set of indicators. Physical indicators, which allow taking into account both the exposure level of a local land use or anthropic assets located in the study area, and social indicators, which allow taking into account social vulnerability, both in terms of population capacity to respond and to cope with hazardous events. The aggregation of physical indicators and social indicators was necessary to derive the overall coastal vulnerability map. Before the analysis of the vulnerability, we needed to define the study area. The study area was defined according to the potential hazards, which were identified during the 0 step of this study. In particular, the study area was identified considering the RICE area. The limit RICE area stands for Radius of Influence of Coastal Erosion and Floodings, which was defined within the erosion project exposure assessment, a project of 2004. The limit in particular was set at a maximum distance inland from the coast of 500 meters and reaching a maximum elevation of 5 meters above the sea level with respect to the coastline. Additionally, we modified the definition of the RICE area, including also a buffer zone of 100 meters inland from the edge of the scarps that we have seen formed by upper coralline limestones. This was made specifically to account for landslide hazard, not only to hazard related to marine processes, but also landslide hazard. The following step of the research was to identify the physical indicators. The physical indicators comprise different categories of assets. A score between 1 and 5 was attributed to each of those indicators, following the method proposed and already applied in different papers. In the table below, we can see an example of what we have done for our pilot study area. For the classification and the identification of physical indicators of the exposure values were attributed not only on the basis of previous studies, but also on the expert knowledge. Collaborating with the local research National Research Center give us an advantage to take advantage of the expertise of local people. Also regarding the evaluation of the value of the exposure. We consider land use elements, transport elements, and utilities. The data were obtained and downloaded from open source database. On the right, we can see the physical vulnerability map resulting from the overlay of the physical indicators, again, land use, transport, and utilities. In order to obtain the vulnerability map composed by the overlap of physical exposure and social exposure, we had to define the social vulnerability index also, not only the physical index, but also the social vulnerability index. Those indexes can be provided directly by territorial authorities or agency, as in the case, for example, of the United States government, or in the case of Italian government. Both provide social vulnerability index. In general, social vulnerability index estimates directly or indirectly the social characteristic of the population living in a certain area prone to be affected by coastal hazard. In our study area, a coastal index was not available. Social vulnerability index was not available for the coastal investigated sector. So we had to develop our own social vulnerability index. In fact, for this step of the research, we considered the information regarding social vulnerability obtained from census data. The social indicators, in fact, are linked to the economic budget allocated by the government for supporting population. We can see that the higher the allocation of social scheme, the higher the vulnerability of the population living in the investigated district. I talk about district because the census data and the social vulnerability data were provided for district. The aggregation of the social vulnerability indicators enables the evaluation of the social vulnerability levels of each of the investigated districts. In particular, for our study area, we choose the following social indicators: health indicator, disability indicators, old age indicator, family, children, and unemployment indicators, where they were classified into 5 classes from 1 to 5. In order to get the vulnerability maps, it was necessary to overlay the 2 sets of indicators, physical and social, in order to provide a zonation of the overall vulnerability. The overall vulnerability was calculated using this formula, also provided by several studies and inspired by the risk kit methodology that I mentioned before. So the overlapping of physical and social vulnerability gives the final overall vulnerability map. Of course, the overlapping was implemented with a GIS tool, which resulted as fundamental for our study. Vulnerability assessment outputs were published in a peer-reviewed journal recently, the last year, and the article also provided an overview on exposure and vulnerability concept, which can be sometimes misunderstood in different research fields and also in the communication through researchers and policymakers. Now I'm going to illustrate briefly the last part of our research. This is a work in progress part of the research, so I'm sorry if I'm going to speak not in detail about it, but some details are going to be defined in the next weeks, because a method for risk assessment, so vulnerability, susceptibility, and exposure assessment should be tailored to the study area. And so our method was inspired to already published works, but should be made tailored to the study case. Starting from these premises, to assess future coastal risk scenarios relevant to sea level rise, it is necessary to evaluate the potential impact of the sea along the coast, here expressed in terms of susceptibility. We weren't able to talk about hazards because in the case of sea level rise, we were not able to define return period because, of course, sea level rise is an ongoing process. The susceptibility and overall vulnerability data were overlaid to calculate the risk level and to provide a risk donation of the investigated territory. Here's again the scheme of the step 2 for the assessment of sea level rise susceptibility, and the step 3 for sea level rise risk assessment. What data were available? What data are necessary for risk assessment? And for applied those index-based approach. First of all, topographic information. We use a DTM, detailed DTM, 1 meter per 1 meter resoluted with accuracy of more than 5 centimeters. We needed local sea level projection from IPCC and global sea level projection. Here in the table, the scenarios provided by IPCC are listed. The underlined scenarios, IPCC scenarios, were considered for susceptibility assessment. Among those scenarios, only 4 plus 1 about the present day was chosen for risk assessment. The scenarios used for risk assessment are highlighted in yellow. SSP refers to shared socioeconomic risks, according to the most recent IPCC report. So, risk assessment can be persecuted by means of risk matrices or formula. But before talking about risk, we have to talk about susceptibility. The susceptibility for our study area was assessed considering the topographic elevation of the investigated sector. In particular, 4 susceptibility classes were identified according to previous studies. S0 corresponds to a safe area, which was excluded from the further risk assessment. S1 includes areas prone to be inundated only temporarily by sea level rise. Area of susceptibility 2 and 3 identify areas that are prone to be impacted by frequent events of temporary flooding due to a combination of sea storm and or fluvial action and permanent morphological changes, such as beach and dunes erosion. And finally, the most susceptible areas are classified in S4 category, which identifies areas prone to be permanently inundated because below the current mean sea level, the considered mean sea level. As already mentioned, risk assessment and mapping can be done with the support of mathematical formula or risk matrices. The main difference between the two approaches is related to the classification of the resulting values. In the case of coastal risks, it can be assessed by combining through a GIS tool the overall vulnerability index varying from 1 to 5 and the susceptibility index varying from 0 to 4 through the following equation, again provided by the RISKIT project, the RISKIT methodology. The obtained coastal index can be classified. They varied from 0, in fact, to 4.5. And they can be classified, for example, as follow into null risk, low risk, medium risk, high risk, and very high risk, corresponding to the class R4. But the coastal risk can be also evaluated by means of risk matrices, which were proposed by several authors in the Mediterranean coastal context, among which Aucelli et al. 2017 and recent work by Di Paolo et al. 2021. Risk assessment using risk matrices can be carried out again by combining through a GIS tool the overall vulnerability index and the susceptibility index. But the resulting values range from 0 to 20, and they can be classified again into 4 classes, R1, R2, R3, and R4. R0 is not considered. But what's the problem? We cannot provide both the methodologies to stakeholders and to policymakers, because as if you remember, our aim is to provide a useful and easy to read tools for guiding management of the land management and sectorial planning. We have to choose how to present our outputs with a coastal index-based approach or with risk matrices. What's possible solution now? We found that a possible solution is compared and ground truthing the outputs of both methodology on the field. We use the expert knowledge of local people, which collaborate in our research group, for choose the correct methodology, which is going to provide the more realistic results. In conclusion, what I have presented is an index-based method which allows zoning the investigative coastal stretch into different levels of vulnerability, susceptibility, and risk related to the sea level rise. What are the advantages of this methodology of an index-based approach. An index-based approach is easy to apply, also to a wider coastal stretch, as you see. Again, it can be found cost-effective because it took advantage of GIS environments, which are almost free. And also the datasets are freely accessible and downloadable, for example, by national geoportals, environmental agency, or OpenStreetMap database. Additionally, the index-based approach is proved to be a valuable tool for decision makers, since it provides them with an outline of an overall vulnerability and sea level rise susceptibility and risk level at local scale. This is the end of my presentation, and here main references regarding the risk assessment methodologies that we followed. Thank you very much for the attention.
Okay, thank you, Vittoria. Yeah, now the session is open for the questions. So already someone has raised her hand. Yes, Aniska from Poland. She raised her hand. Aniska, go ahead with the question. Yeah.
Hello. Thank you for a very interesting presentation. I want to ask why different sea level scenarios were used for the risk assessment and the sustainability assessment.
Thank you for the question. Yes, we use different scenarios in order to compare them, the risk related to certain scenarios in consider different time, different periods. And so we would like to provide stakeholders, we would like to provide an output which not only take in consideration the medium term of sea level rise, but which is 2050, but also a long-term sea level rise, which is 2100. And we would like also, in the next step of the research, to compare those scenarios. We prefer, one thing I would like to mention is that we prefer to use local scenarios with respect to global scenarios. So for the risk assessment, we are going to use only local scenarios and not global scenarios. The scenarios refers to medium term 2050 and long term 2100. So different scenarios of sea level for different values, for different consideration about risk, sea level rise risk.
Okay, but if I understand correctly, there were different scenarios for risk assessment and different for sustainability assessment. Wasn't it better if it will be the same scenarios for both of these assessments?
Okay, no, the scenarios are almost the same, but for the susceptibility assessment, we considered more scenarios. Okay, and among the scenarios used for susceptibility assessment, we selected 5 scenarios for risk assessment. So actually, the scenarios are the same. Only in this preliminary phase of the susceptibility assessment, we consider a wider spectra of scenarios.
Okay, thank you very much.
You're welcome.
Thank you, Aniska, for your questions. And may I ask the others? Yes, Navonita. Navonita is actually, I think she got her admission in the same University of Victoria. You know, both of you, I think you know each other, maybe.
Yes, actually, I heard of her. It was an outstanding presentation, Dr. Vittoria Vendali. So I just have one question to ask. So what are the different other techniques apart from this index-based parameter? Any other type of techniques that we can use in order to understand the impact of climate change on the Mediterranean shores?
Yes, there are. I think that our researchers think that index-based approach is more easy, also easy to apply. But there is also a model which considered very complex scenarios. Okay, so model-based approach account for numerical modeling, which is quite difficult, and we don't have the resources to approach such a method. But I think that index-based approach, in its simplicity, can provide a really easy readable tool for stakeholders and policymakers.
Thank you so much.
Okay, so anyone else? Please go ahead. Add 1 more minute. Yes, I'm not sure who is raising the hand. Anyway, I cannot see anyone else. Please, anybody who want to ask any question, please go ahead.
I have one more question.
Oh, Agnieszka, you again. Yeah.
I want to know if you, because I think that you use some interpolation method in ArcGIS. So if you used which one and why?
No, actually, we use just we apply the formula by the product of vulnerability and susceptibility, applying the formula just directly using a raster tool in GIS. We didn't use, in fact, this is a very nice thing of this method. We use just simple, basic raster tool in GIS. By the overlapping, applying the formula with a simple raster calculator, susceptibility and risk, or in the case of vulnerability, exposure index related to physical vulnerability and social vulnerability. So just with a normal tool raster calculator. So
okay, thank you.
Welcome.
Thank you, Agnieszka, once again. Okay. Who is there? Arindam Chaudhary, please
Hello.
go ahead. And keep the question very short, please, because this is going to be the last question. And just Victoria, can I just put your email ID on our chat box, because I'm sure many will be interested in this particular topic and they can ask some questions, so that I will give your email ID. Is it okay for you?
Yes, sure, no problem.
Yeah. Then I'll just put this email ID on the chat box and they can easily question you. So this is going to be our last question for this first lecture. So Arindam, please go ahead and keep it short. Please. Okay.
Yes, it's a great presentation. Like I have one question in my mind, that in this route, Mediterranean route is very crowded, like for the ship passages. So the passage of big ships means kind of a human interventions. Passage of big ships near this region, that's Maltese archipelago, leads to big tides and lateral spreading or lateral erosion.
Yeah. Also, we didn't evaluate the risk for the moment related to landsliding, but this is one of the future research steps, of course. And the area, of course, is affected by hazard related to landsliding, lateral spread, and other gravity-induced processes such as lateral spreading. And so, as you can see, the gravity-induced slope landforms represent an impressive source of hazard for the archipelago. Even if they are slow-moving, they can collapse.
Okay, then, Victoria, thank you once again for joining. And it is my request to be here until the end of the lecture session, if it is possible for you, because you know Adolfo will come at last. Okay, so you please be here, and if possible, listen to all the lectures. I'll be very glad. We will be very glad if you are here. Okay, so thank you once again, Victoria. Thank you. Thank you. Okay, so I'm moving to our next speaker. So we have a lot of people lined up today from the Mediterraneans. So our next speaker, Fran is also from the Mediterraneans, and most importantly, I think he's probably the youngest speaker today. Okay, in fact, the youngest speaker of our entire program. So please welcome, I would like to welcome Dr. Fran Domazetovic from Croatia. And he is a postdoctoral researcher at Geospatial Analysis Laboratory at the University of Zadar, Croatia. And he specialized in GIS and remote sensing with a PhD in geospatial technologies. And being the scholar of geospatial technology, he expertly deals with very high resolution digital elevation data in soil erosion modeling. And he basically insisted me to put this, this particular phrase, very high resolution data, in the topic title, because he indeed works with the very, very high resolution data sets. So you'll see that. And his work has been published in renowned journals like Geomorphology, Natural Hazards, etc. And most importantly, he's another IAG young geomorphologist, and he was a participant in the second IAG intensive training program that took place in Greece in 2019. Okay, so Fran, a very warm welcome to you once again, and you may share your screen.
Thank you very much, and thank you for really welcome introduction. Hello everyone, I will share my presentation now. I'm hoping that you can hear me well and without any errors. Okay, just a second. So can you see the presentation?
Yeah, it is coming. Yes.
Okay,
fine.
Perfect. So the topic of today's presentation will be application of very high resolution UAV mapping in geomorphology. It's a really broad topic, and it's a really new and developing area in geomorphology and in spatial technologies in total. In this presentation, I will start with some basics of UAV mapping and its application in geomorphology, and then I will switch through the presentation to the case study which I did within my PhD, which was related more to the soil erosion monitoring at Pag Island, Croatia. So this presentation will cover the basic introduction to very high resolution UAV mapping. We will cover different types of unmanned aerial vehicles or UAVs. Also, I will try to explain in some small details different types and applications of different sensors that are possible to mount on UAVs. Also, I will talk a little bit about advantages of UAV mapping from geomorphological perspective, since the UAV mapping really makes some field works easier and quicker. Also, I will talk a little bit about the differences between LiDAR and photogrammetry mapping approaches as two main UAV mapping approaches that are used today. And I will cover basic steps of very high resolution UAV mapping. So my goal was that after this presentation, you will be able to do similar research and similar fieldwork using UAV mapping by yourself, or that at least you will have some clue what steps you need to include in such research. And we will cover all 5 steps which are part of very high resolution UAV mapping. And then the last part of presentation will cover actual application for soil erosion monitoring. So UAV mapping is a quite new term because the whole discipline is developing for the last 10 to 20 years, parallelly to the development of different UAVs and UAV mapping systems. And it basically includes application of various unmanned aerial vehicles for acquisition of geospatial data and creation of very high resolution models. Very high resolution is very important because with such UAV mapping systems, you are basically able to produce sub-decimeter spatial resolution models. So by some definitions, all models that are which have a resolution under half meter are considered very high resolution models. And you will see through these presentations that most of these models that I used for my PhD have a sub-decimeter spatial resolution, or spatial resolution about 1 centimeter, 2 centimeter, depending on the flight conditions. The main advantage of UAV mapping is that you can basically produce 2 types of models. digital orthophoto image, which you can see on the right side, on the upper right side, which has the texture included, so you can differentiate between different soil types, between different vegetation types, between different rock types. And it's really useful for interpretation of the study area. And then the second product is digital surface model, which includes the terrain characteristics and in most cases everything else that is placed atop the terrain, so like dry rocks, some vegetation, and so on. And this can be used for morphometric analysis, hydrological analysis, for spatiotemporal changes, and quite other range of different applications in geomorphology. Basic components of a single UAV mapping systems can be divided into three parts. The first and the most important part is UAV itself, or the unmanned aerial vehicle, which carries the whole system and which is responsible for the flight of the whole system. Here on the left side, you can see one of the most currently advanced copter UAVs called DJI Matrice 300. Then the second components are sensors or data collection units, which are responsible for collection of certain types of data. We'll cover this later through the presentation. There are many different types of geospatial data that you can collect in the field and which can be useful in your geomorphologic research. And the third part of the UAV mapping system is flight planning application. This is basically the software which is responsible for the automation and performance of the flight itself, in which you can define the characteristics of the flight over your study area. In regard to the different types of UAVs, I have to say that it's very important to choose an optimal UAV for your research, because there are many different UAV systems which are different in design, flight capabilities, number of sensors that they carry, maximum weight that they can carry during the flight. So basically the selection of optimal UAV mapping systems should be adjusted to your survey goals and characteristics of your study area. Most UAVs are either fixed wing UAVs, which you can see on this left example, this airplane looking UAV, or multi-rotor UAVs like the one on the right side of this slide. Both of these types of design have its advantages and shortages, and it really depends on your research goals, which one of these designs is better for your research. For example, fixed wing UAVs can cover larger areas because due to their design, they have a longer flight time and greater speed of flight, but they are better for flat areas because they require larger area to take off and take down, and they are not adjusting the flight altitude so well to the terrain characteristics. On the other hand, multi-rotor UAVs are better for surveying of complex terrain features, like gullies, like landslides, like volcanoes, and similar geomorphological features, because they have larger motors and they can follow the terrain characteristics more better than the fixed wings UAVs. This is just a review of different UAVs and UAV mapping system that we have currently within our geospatial analysis laboratory. Basically, we started almost 5 years ago with a basic DJI Phantom 4 UAV, which is really basic entry-level drone for UAV mapping, but which can also serve as a really good and accurate UAV mapping system. And then through our projects, we evolved to larger and more complex UAV mapping systems, like the Trinity F90 fixed wing UAV mapping system, or DJI Matrice 300, which can be equipped with more than 20 different sensors. So there is really a variety of different UAV mapping systems designs, And it's really important that you know what you need before you choose the optimal water for your study. In terms of different UAV sensors that can be mounted on UAV mapping systems, there are probably a lot more different sensors that these 4 groups that I have put here, but these are the most common 4 groups which you will probably find in most researches that are regarding collection of geospatial data. First type of sensor is aerial lidar sensors, which are used for accurate point cloud acquisition, and their application is mainly for creation of very high resolution and density point clouds and digital surface models, which can then be used for spatial monitoring and spatial temporal changes, for geomorphological mapping, and so on. There's a wide variety of different applications. Limitation of this type of sensors is their costs. Some basic entry-level sensors are costing over $13,000. So it's the most expensive type of sensors that you can put on the UAV mapping system. However, it achieves really great density of collected points, and it can achieve even sub-centimeter resolution of created models. Also, as I will show you later in some examples, it's great for mapping over highly vegetated areas where you have a dense vegetation cover, which obscures some other sensors from seeing the actual topography of terrain. The second group of UAV sensors are RGB cameras, which basically have the 3 visible spectral bands, red, green, and blue. And these are used for acquisition of typical aerial images, which you're probably all familiar with. These images can be used in some processing software for creation of very high resolution digital surface models and for creation of digital orthophoto images. Their main advantage is that they are, in comparison to LiDAR systems, much cheaper. The starting price of some professional grade sensors is over $1,000, but as I told you, there are even some cheaper solutions. Then third group of UAV sensors are multispectral cameras, which have a possibility of acquisition of images in different spectral bands, similar to some satellite sensors like Landsat, Sentinel, and so on. So basically, you can collect multispectral images that you can then process and make like an individual multispectral image of the whole area with, let's say, 5 or 10 different spectral bands. And the application of such models then is mainly for classification of different spectral features, like different outcropping lithological units, for vegetation classification and production of land cover maps, and so on. They're a little bit more expensive than regular RGB cameras, and their starting price is around $5,000 up to tens of thousands of dollars. And the fourth group of UAV sensors that I wanted to introduce you with is thermal cameras, which are quite new and probably the newest from these 4 groups of sensors. And these are mainly used for acquisition of thermal aerial images. They have great application in detection of thermally heterogenic features, such as underwater springs, soil moistures, volcanic activity, and so on. We started working last year with one of these thermal cameras, and it's really, really great for detection of let's say, underwater sea springs, which are quite common in Croatia. A little bit about main advantages of UAV mapping systems. There are many advantages of UAV mapping systems over other similar geospatial mapping approaches, but I have put only these 4 as the main advantages that are the most important. First one is very high resolution and accuracy of created models, which can be hard to achieve with some other traditional fieldwork techniques. Secondly, possibility to survey large, remote, and potentially dangerous areas of complex terrain, such as active volcanoes, active landslides, heavily gullied terrains, etc., which are much easier to cover with a UAV mapping system. The third advantage is reasonable price of UAV mapping systems. In most situations, they are much cheaper than some other geospatial technologies, especially the terrestrial ones. And the field costs of UAV mapping are much cheaper than in case of also some other terrestrial geospatial technologies, because the fieldwork itself is much quicker and the drones cover much larger area. And they are suitable for various types of geomorphological research. In my research, I'm focused on detection of spatial temporal changes, but there's really tens of different other applications that can be used in geomorphology, and I will talk about some of them also a little bit later. So I told you that with such UAV mapping systems, you can achieve very high resolution and accuracy of created models. For this type of advantage, I have put this example from my PhD, where we did the comparison of point cloud generated by the UAV mapping system, which we compared with the reference LiDAR data collected on the field with the terrestrial LiDAR scanner Faro M70. So at the end, after the UAV survey carried by our aerophotometric system, we generated the point cloud with around 125 million points that were collected within only the area of only 1,100 square meters of heavily gullied terrain. So you can imagine the density of such point cloud. And when we compare this point cloud with the reference LiDAR point cloud, the determined deviation, which was calculated by the N3C2 algorithm in Cloud Compare software, was only around 2.5 centimeters, which basically means that our minimal level of detection for spatial temporal changes for soil erosion was 2.5 centimeters. And if you think that this was done with a UAV mapping system, which is much cheaper than the terrestrial LiDAR system, then this is the real advantage of the UAVs and use of UAV mapping systems. And this point cloud, so these 125 million points were used for the creation of 1 centimeter resolution digital surface models that were used in the study. Also, I mentioned the possibility to survey large and remote areas and also potentially dangerous areas. This is very important if you are working in some areas that could potentially be dangerous for humans or for direct field works. Since you are basically, you can send a UAV mapping system to survey some area which is let's say 500 meters or 1 kilometer from your position, you can basically stay on some road or on some field which is outside of the that remote and potentially dangerous area, and you can still make the survey above that dangerous area. For example, I have put here the models created from surveying, UAV mapping surveying over volcanoes, which I think are the best example of such a potentially dangerous area, which you can survey with UAV mapping system. Also, the great advantage of UAV mapping systems is that they can be equipped with different sampling units, so that even if you need some sample from the field, like sample from the water from the lake in the crater of volcano, you can easily send a drone over the lake and then just take the sample of water by the drone, so that you don't have to go inside of the crater by yourself. Also, a single UAV mapping system usually covers much larger area than it's possible to cover with a direct human fieldwork. For example, even the basic DJI Phantom 4 UAV mapping system can cover in single grid mode over 35 hectares of area with only one battery. So in one day, easily you can make a survey over a few square kilometers of rough terrain. And in many cases, created models, so digital orthophoto images and digital surface models, are due to the very high resolution detailed enough that sometimes even a direct contact with the surveyed surface is not required. Because if you produce a very high resolution digital orthophoto of, let's say, 1 centimeter, you will basically be able to see all the rocks which are larger than the spatial resolution of 1 centimeter, which is quite detailed. And it's really easy then to do the mapping of lithological units or anything else in which you are interested. Also, I mentioned the relatively reasonable price. I want you to remember that UAV mapping system doesn't have to be expensive. The best example for these are different entry-level unmanned aerial vehicles like the DJI Phantom 4 Pro, which we really use for 3 years in different scenarios and over different terrains. And in my opinion, it's still one of the best entry-level UAVs because it has advanced camera with 20 megapixel camera, which is perfect for creation of very high resolution models and of really detailed aerial images. It's really compact and it has light design, so it's easy to carry it and operate with it during the remote fieldworks. Sometimes it's really problematic with larger UAV mapping systems to carry them on the field because in Croatia, most of the areas in which we work are covered by limestone. So if you don't have some road and if you cannot use a car, then it's hard to reach some areas and to use larger UAV mapping systems. Phantom 4, on the other hand, you can put in your backpack and you can hike somewhere and then just take off from some position that is good for you. So that's the real advantage from it, and it's really fast and durable unmanned aerial vehicle. And also the main advantage of this drone is relatively small price. The price of fully equipped UAV mapping system is around 2,000 euros, while some more advanced UAV mapping systems can be over $25,000. So much higher. And also, as I mentioned earlier, UAV mapping systems are suitable for various types of geomorphological research. If you want to do some detection of spatial temporal changes caused by geomorphologic processes like soil erosion, coastal erosion, alluvial accumulation, and so on, then you can apply UAV mapping systems for interval surveys and for interval creation of very high resolution models, from which you can calculate the difference between the initial state and the final state of the certain study area. Also, UAV mapping systems are great for the monitoring of natural hazards and UAV mapping of the damage caused by the natural hazards, which was best seen in Croatia last year after the big earthquake that struck some parts of Croatia, where UAVs were used for the aerial reconnaissance of the damaged area, which is then less potentially dangerous for humans, and also it's quicker because drones cover the large areas of the damaged area. These models also can be used due to the very high resolution for risk assessments and for post-hazard damage mapping. And one of the newest applications of UAV mapping systems is very high resolution mapping of specific geomorphological features, like the 3D documentation of geoheritage, which can then be used for the future protection and reconstruction of let's say natural parks and similar sites that are important due to its geoheritage importance. I told you already that two main approaches in UAV mapping are either LiDAR or either LiDAR, so LiDAR sensors that are mounted on the different UAVs, or simple photogrammetry, which is considerably older and more common technique. LiDAR basically works on a terrain reconstruction based on point cloud collected by laser beams projected from the sensor mounted on the UAV. And these sensors are developing every year, so the density of collected point clouds is getting higher and higher. Now it's normal that you have some sensors which can collect up to 500,000 or 1 million of points per second. And when you have such great density of collected point cloud, then you can create sub-centimeter resolution models, and also you can do a lot of filtering, so you can remove all the things that you don't need in that point cloud. For example, vegetation cover, which can sometimes obscure the surface, and in case of photogrammetry, which can cause you a lot of problems. So that's great advantage of LiDAR. And the good thing with LiDAR and LiDAR mapping is that LiDAR sensors are getting every year cheaper and cheaper. So it's not so expensive as it used to be a few years ago. On the other hand, in case of photogrammetry, photogrammetry is based on terrain reconstruction using the aerial images collected by professional grade camera mounted on the drone. It also can produce sub-centimeter model resolution if you are flying low enough, and its accuracy is a little bit lower than in the case of the LiDAR in most cases. But if you are using ground control points, so permanent points with known location, geographic location, then you can also achieve centimeter accuracy of your models. Here on these photos, you can see the visual comparison of these two approaches. So LiDAR on the right and typical photogrammetry on the left. As I said, both approaches have certain advantages and disadvantages, and the choice between UAV photogrammetry and LiDAR depends heavily on the exact application and availability operational factors. On the first hand, these are survey cost and complexity. Sometimes, if you have a really complex terrain, LiDAR will work better because these sensors are projecting a large number of different laser beams and are better to scan the complex terrain features such as overhangs or rock cliffs, which you can basically see on these two models. So the upper one is the part of the gully headcut, so really steep and some parts even overhanging part of the gully topography, which is scanned by LiDAR, and you can see that the point cloud managed to reconstruct most of this complex topography. On the other hand, photogrammetry managed to reconstruct most of the slopes of the gully headcut, but it had really significant problems with these shaded areas, so that were in shadow during the actual survey, or the areas which were overhang, so that were blocked from the RGB camera that was used in this UAV mapping system. And also the really important factor again is price, because the professional grade photogrammetric system cost between $10,000 and $30,000, while the similar UAV LiDAR system cost much higher, so between $25,000 and $120,000. So that's why I prefer maybe photogrammetry, because it's more common and it's more available than LiDAR. But both are great techniques, and if you're able, of course, the combination of these two is really, really good also. I told you about the problems which photogrammetry can have with the vegetation. This is just one example from my study area, where in few summer months there was a huge growth of this Articum lapa plant, which in few months grow by even in some cases 10 centimeters. And of course, since the spatial resolution of created models was 1 centimeter, then all these plants were visible on created models, and they represented artifacts which had to be filtered. Sometimes if you don't manage to filter these artifacts, when you make the calculations and you calculate for, let's say, the volume of the change between initial and final state, you can get the false interpretation, because these artifacts created by vegetation will be interpreted by the software as accumulation of material, which is of course not the case, because it's not a geomorphological process. It's a natural biological process which doesn't have, in this case, any connection with the soil erosion. On the other hand, LiDAR successfully overcomes this problem, as you can basically remove not only this plant, but also all this grass which is present on this soil slope. So the whole process of UAV photogrammetric mapping can be divided into following main phases. First one is flight planning, in which the flight planning software is used for the automation and optimization of flights. Then the field preparation, the collection of ground control points and checkpoints. Third step includes flight missions, so the actual flight with the UAV mapping system and the data acquisition with the system. And the final steps are data processing or the model creation, and at the end, model application for the purpose that you have intended. These are, of course, based on the photogrammetric approach, because I can choose this approach as it's more common and cheaper than the LiDAR one, and it's easier to apply it than the LiDAR one. The flight planning phase, the first phase, includes the automation of flight missions, where you can basically define different user-defined parameters of the flights that you will take on the field, such as front and side overlap, which has to be over 80% for the good coverage of photometric model. Then the flight height, which directly influences the spatial resolution of the model that you can extract from the collected aerial images. For example, since I wanted spatial resolution of my models to be around 1 centimeter, flight height with my UAV mapping system had to be around 26 meters, so quite low. Also, you can define flight area, so which area you want to scan with your mapping system, and grid type, double grid or single grid. This is just the pattern which the drone uses, and which also has to be adjusted according to the terrain characteristics. And one really important user-defined option is terrain following, which is really important in complex terrains such as gullies, because with this option you can define that your drone follows the terrain characteristics. So you can basically input the lower resolution digital surface model, and then the drone will automate the flight according to the heights in this model, which is really useful because you get the unique spatial resolution over your whole survey area. Then the second step is field preparation, so the collection of ground control points and checkpoints. Ground control points are basically the points with a known geographic location, which are crucial for achievement of model absolute accuracy. This is basically the most important step in all studies that are doing interval surveys. So basically all studies that are covering spatial temporal changes of some area. And there are also quite some rules about these ground control points and how they can be used. First of all, they should be distributed in whole study area, and your survey should have at least 3 ground control points. But of course, the more is better, because you will get the better accuracy and better coverage of your study area. And for longitudinal researchers such as spatial temporal detection, your ground control points have to be identical. So if you do one survey this year and then the second survey next year, you have to have identical ground control surveys. This is how it looked in the case of our study area. So we basically marked the locations in permanent locations in limestone, which were then marked with the red spray and this black stick. And the location of every ground control point was collected with the RTK real-time kinematic GPS, which even in remote areas achieves centimeter accuracy of the models. The third steps includes flight missions, which should be performed in optimal weather conditions. So UAV mapping is highly weather dependable. Basically, if you have strong wind or rain, you cannot fly because you will have problems with your UAV mapping systems, and it can really influence the accuracy of the whole mapping process. And also, it's not really recommended to do the flights during the really sunny weather when you have like large shadows. So the optimal weather is without any rain, without any wind, and with cloud cover which blocks all the shades, which is sometimes really hard to achieve in the field. And during my PhD, it was hardest to find the optimal days to go and perform the flight missions. And the two last steps are data processing, or the creation of digital surface models and other models, which you can do in many different photogrammetric softwares. For example, Argus of Metashape, Pix4D Mapper, Imaging Photogrammetry, and so on. And this step is also really important because processing methodology will directly influence the accuracy of your created models. Here on the right side, you can see the methodology that I applied for creation of digital surface models in Argus of Metashape with all the user-defined parameters. And last step is model application. So the application of created models for the purpose that you have intended for that model. Now I'll just shortly present you the results of application of UV mapping for monitoring of soil erosion intensity, which was done at Pag Island, Croatia. As you probably know, soil erosion is a mechanical wear of soil under the influence of different erosion agents, which influence the erosion of soil particles, transportation of eroded materials, and sedimentation of eroded material. It's a really important process because it's recognized as one of the greatest challenges for sustainable soil management. And in EU, they consider soil erosion as one of the biggest threats to all agricultural lands within the Union. Although it's a natural process, it's also accelerated by different anthropogenic pressures and climate change. So the situation in Croatia is better than in some other areas of Europe, because Croatia is in general moderately endangered by soil erosion. But some parts of Croatia, especially the coastal parts where there is no really a lot of vegetation cover and where soil sediments are exposed to different erosive factors, these soil erosion rates can be much higher and can be more similar to some other parts of Mediterranean in the world, which are known about really intense soil erosion. These are just some of the examples of soil erosion sites in Croatia. This is on Rab area, Rab Island, which is north from Pag, our study area. Then this is Radovin, close to Zadar and our university. And this is Pag, the gully which we studied within this PhD. Basically, all these three sites are within the radius of 100 kilometers. So this whole area is really affected by the soil erosion. The UAV mapping was just one part of the PhD. It covered this meso level of research, while the macro level was more concentrated on satellite imagery and creation of 1 meter spatial resolution models for the whole island for the area of 284 square kilometers. And micro level was more concentrated on the use of terrestrial LiDAR scanner for the sub-centimeter modeling. Research goals related to the UAV mapping were determination of spatial temporal changes caused by soil erosion within the selected gully through the application of interval UAV mapping surveys. Second goal was accuracy assessment or the comparison of UAV photogrammetric models with the reference LiDAR data. This is related to the slide which I showed you earlier about the accuracy of created models. Third goal was to determine the spatial distribution and intensity of main soil erosion sub-processes such as sheet erosion, real erosion, headcut retreat rate, and so on. And the fourth goal was to determine the dependence of the soil erosion intensity on the lithological characteristics of the whole area. Since we have really small area of, let's say, 14,000 square meters, we were able to do really detailed lithological map, which were then able to correlate with the soil erosion intensity. This is the location of our study area. So the whole Pag Island is known for really scarce vegetation cover and intensive soil erosion with several hundred active gullies. On this picture, you can see the typical landscape of Pag Island. Basically, the remaining soil sediments are very scarce and they occur only in these depressions where they are exposed to different erosive agents like wind or precipitation. And this is the map of Gully Santish. So this rectangle was the study area in which we performed the UAV mapping, and this area here is the watershed of the gully from which receives all the overland flow. The whole area is known about really nice soil erosion features like different gully headcuts. There are actually beside Gully Santish 5 other gullies in this area which have recent traces of gully erosion. And on the right picture you can see the Gully Santish photographed by our drone from about 100 meters from the gully. I'll just try to show you the 3D model of the gully. I'm hoping that you can see it without the presentation. So this is the 3D model of the whole gully. It has 2 gully headcuts. One is the upper one, and this is the second, the larger one. And these 2 are the biggest erosive zones for removal of the soil. And this is the main gully channel through which the most of the eroded soil is transported to the sea. And at the end of the gully, which is about 80 meters long, is an Adriatic Sea where most of the eroded material is being accumulated over time. So it's being basically lost. Okay, back to presentation. So, as I already told you, we did the UAV mapping interval surveys over the Gully Santish, which used our RAPS system, so repeat photometric system, that was composed of DJI Matrix 6000 Pro drone, equipped with the Grenzy T3 gimbal and Sony Alpha professional camera. First part of this research was published in our paper in remote sensing at the beginning of this year, but we still haven't published the final details and the final soil erosion intensity that we managed to detect. For the purpose of interval surveys, we constructed the local coordinate system, which consisted of 7 ground control points and 6 checkpoints, whose locations were collected with the real-time kinematic GPS. You can see here the distribution of ground control points, the red ones, and the checkpoints, the white ones within the Gully Santish. And here on the left are the missions, the flight missions that we planned in UGCS software application. This is one of the permanent ground control points that we used within our study area. And these are the identical locations measured with the RTK GPS on the field that were used for creation of all models. So the first UAV mapping survey was done on December 2019, and the second one was performed on December 17, 2020. So we had a time period of 1 year, and around 1,500 aerial images were collected during each survey, from which we were able to create 1 centimeter digital surface models. Also within the study area, we collected meteorological data. From the meteorological data, rainfall intensity and distribution was collected, as well as air temperature. And as I told you, soil sampling was performed to see how homogeneous the soils are at the study area, and lithological mapping was conducted just to know which lithological units are present within these 14,000 square meters. So from the comparison of models created by UAV mapping, we detected that soil erosion was present at only 150 square meters of gully frontage. So it's really located in these erosion zones related to the gully headcut and the main channel. And in total, in this 1 year period, around 13.5 cubic meters of soil were eroded, while 85% of this soil was accumulated within the gully itself. So only about 1.9 cubic meter of the soil was transported directly to the sea, which also shows that the transport capability of the overland flow in this 1 year was very low, because it was able to erode the material, but it wasn't able to transport it further from the gully headcut. And also, we realized that the soil erosion intensity was lower than within previous years, in which we also did the monitoring, because of the prolonged dry periods within the period between 2019 and 2020. This is just the map of the distribution and intensity of detected spatial temporal changes. You can see that most erosion is present within the lower and the upper headcut, and also in this area where selective erosion was really strong in this period. Also, we researched the influence of slope on soil erosion intensity, where we correlate the slope classes with the soil erosion intensity. And this was really interesting because it showed that most of the erosion is detected within 2 gully headcuts, or to say within steep slopes with the over 55% of steepness, which cover only 3.5% of the total area, but in this area was detected almost 50% of all soil erosion. On these images, you can see the field photos of these 2 gully headcuts, which were responsible for the most of the soil erosion. So the upper one, which is located at the beginning of the gully and which is a little bit smaller, and the lower one, which is about 20 meters wide and 2 to 3 meters deep, and which is responsible for most of the soil erosion. Also, using the very high resolution models that we create, I was able to detect the new erosion zones, the activation of new erosion zones, which are related to the formation of the new gully headcut between 2 existing headcuts, or to say to the formation of initial steps, which represents the beginning of formation of gully headcut. These are results of the lithological mapping, which were used for the research of impacts of lithology on soil erosion. So in total, we mapped 9 different lithological units, which were correlated with the soil erosion intensity. And this correlation showed that most of the erosion occurred within the brown earth soils, which were most susceptible to soil erosion, and also within the carbonate sandstones, within which selective erosion occurred. So this is this selective erosion event which the models managed to represent. This is a situation in model created in December 2019, and this is the situation in the same model created from the images and the UAV mapping which was done in December 2020, and this was the detected change. So the detected erosion in red and accumulation in blue. And this is the photo from the field which represents this whole change. This selective erosion is really important, and it really rises the intensity of erosion within carbonate sandstones. But during the field work, we realized that it's not so often as the mass movements and other erosion processes that are present at the brown earth lithological units and in gully headcuts. This is the situation in the gully headcuts, where a significant uphill retreat of gully headcut was detected, which is responsible for greatest contribution to soil erosion within brown earth soil deposits. And also, really large diversity of erosion processes is present within this lithological unit. So from raindrop erosion to sheet wash, real erosion, all the way to the mass movements, which are responsible for the largest changes in the gully morphology. Also, from the models, it was noted that most of this material is accumulated within the few first meters of the gully headcut, because the overland flow, the surface flow is not strong enough to transport this material further away from the headcut. These are some other interesting examples from the detected within the gully. On the left side, you can see a sheep which died during this 1 year period, and which was detected by the created models as accumulation. So basically, I was able to calculate how much material that sheep accumulated in this gully, which of course was extracted from the actual geomorphological change caused by soil erosion. But this is just to show you how detailed these calculations can be. And also on the right side, you can see the accumulation of soil below the main gully headcut and accumulation of soil and rocks on the pebble beach at the end of the gully, which were transported along the main channel. These all were basically the changes detected by digital surface models, or let's say raster-based methods. I wanted to show you just that it's possible also to use point clouds created by either LiDAR or UAV photogrammetry for detection of spatial temporal changes. In this example, you can see the one small part of the gully headcut with around 25 million points, which was created from UAV mapping conducted in these two dates, where I used M3C2 algorithm in Cloud Compare for comparison of 2 point clouds and a calculation of the change that have occurred. The advantage of such 3D point cloud approaches is that they can represent better the 3D complex topology, morphology of the gully, such as these overhangs in the steep walls of the gully headcut. So the calculation is more precise than with the raster models. In conclusion, UAV mapping is really affordable survey technique, which is suitable for mapping over complex and remote terrains and creation of very high resolution and accuracy models. It's cheaper, faster, and more accurate than most other field surveys and most other geospatial technologies. And because of that, I really encourage you to try to use it and apply it in your research. And also, the main advantage of UAV mapping system is that they can be equipped with different sensors with wide range of different potential applications. So you can basically adjust your UAV mapping system according to your research needs and goals. As I showed you from this example in regard to soil erosion, very high resolution models are really a perfect basis for detection and quantification of different spatial temporal changes. And if you apply it with all these steps, you can achieve sub-decimeter spatial temporal changes detection and accuracy of under 5 centimeters, which is really great for relatively cheap geospatial technology. And that's it from me. I'm hoping that you have some questions and that you will start using UAV mapping in your researches, or that you are already using it and that you have a lot of fun and productive research with it.
Okay, participants, go ahead with your queries. Thank you, Fran, from your deliberation. It was a very interesting topic and obviously a new one. And yes, we are heading towards some kind of change as far as the technological advancements and applications in geosciences is concerned. So, from that point of view, your topic is a very important one. And yes, if you have any question, dear participants, you go ahead with your query, please. Anyone, please, especially the people who are working in high resolution, who are working with high resolution data sets. Please go ahead. Yes, Marin Mijunovic, I think he's from the same region. I think he's from Croatia.
I know Marin.
Yeah, Marin, please go ahead and ask the question, please. Turn on your camera and ask the question, please. Yes, Marin, we are waiting for you. You turn on your camera and mouthpiece and ask the question. I'm not sure if he's there. Anyone else, please? You can also put your question in the chat box. And friend, I can do one thing. I can share your email ID if it is okay with you.
Yes, please do that. And please, everyone, if you have any questions, I'll be more than happy to help you with your research.
In fact, Fran is asking for questions. So you please go ahead. I'm sure many will be interested. I have problem with microphone, Marin is writing. Okay, Marin, if you can listen to me, you can put your question in this chat box itself. I will read it out. No issue. So I've just put Fran's email ID here. Yes, I just wanted to ask, Marin is saying that I just wanted to ask, which flight planning application have you used? Is it open source?
Okay, that's a great question. For my PhD, I used UGS flight planning application, Universal Ground software, which is not, unfortunately, open source. It's commercial, but the good thing is that you can get the license for much lower price if you're working on university or if you're working on your PhD. They're really helpful in terms of that. This application is great because it allows some advanced user-defined parameters such as terrain following, but also there are some open source applications which are really great, and you can basically do the same modeling with these open source applications.
Okay, then we have another. No, it's not a question, just a query. Tatenda Musasa, he asked for the email address. Actually, Tatenda, I have already shared the email address in this chat box. And thank you so much. Tatenda, why don't you do one thing? You can ask your question here. Obviously, you can contact Fran afterwards, but you please go ahead and ask your question here. Tatenda, if you are there. Anyone else? Working with UAV? Working with drones?
Hi there. Hi.
Yeah, Evie, go ahead, please.
Oh, no. The only thing that I needed to ask is about the resolution, because I didn't hear very well, friend. What is the resolution of the drone mapping?
That's also a really good question. So it basically depends on your UAV mapping system, so which camera you have mounted on the drone and how high are you flying. So basically with DJI Phantom 4, which is a entry-level model, if you're flying at, let's say, 100 meters, you can get 3.5 or 4 centimeter resolution. If you have some more advanced system, or if you're flying lower, then you can get even better spatial resolution.
Okay, thanks a lot.
Okay. So I'm asking for the last time if any question is there. Yes, Arindam Arindam Chaudhary, he's asking that how do you map the vertical drops which we can see in your map having shadows near the gullies? Okay, so he's basically asking how are you negotiating these shadows within the valleys? How you are?
So that's excellent question. Also, in this case, you have to be careful a little bit. So you have to either make a survey when it's not sunny, so there is no shades, or you can adjust your flight mission that it covers these really steep areas. If you still have some problems, then you can even combine some different geospatial technologies. So the best case solution for like such complex features will be to combine, let's say, UAV mapping, like UAV photogrammetry, and either terrestrial photography or terrestrial LiDAR, so that you can get really good coverage of these complex areas. But it's not really easy always, believe me. If you have really complex topography, then you really need to plan your flight missions really well.
Okay then. So if there is no more question, I'm telling all the participants once again that I have already put Fran's email ID. You can get it from the chat box and you can contact him afterwards. So yes, Tatenda Musasa, Marine once again use Tatenda Musasa, please go ahead. We can take one last question. Please go ahead. You have raised your hand. Tatenda, please open the camera and mouthpiece and ask your question. We are waiting for you. Mike, there is my question on the chat box. He's writing. So I'll go to the chat box. Here, I am having challenges with my network. Okay. Just wanted to ask how we can apply UAV mapping to resolve world problems, for instance, in the field of geomorphology, in case I missed the application part. Okay, in hardcore geomorphology, suppose someone is doing geomorphological mapping, maybe in coastal environment or fluvial environment, suppose in the gorges, in the high mountainous regions. So how can we apply UAV mapping? It's a very basic question he has asked. So in general, how will you negotiate with different kinds of problems?
So basically, if you have some study area that you want to make a survey, you can go and take your UAV mapping systems and you can scan the whole survey and create the better data for that survey that it's possible to get from some other sources. Like, of course, you can download satellite images, or you can even buy satellite images from some companies. But this resolution is not so good as the data that you can get from UAV mapping systems. Also, in Croatia, for instance, geological maps and geomorphological maps are not so detailed as the models which you can get from UAV mapping. So that's one possible application. You can use UAV mapping for creation of very high resolution models, and then for the update of geomorphological maps, geological maps, etc. You can also use it for monitoring of active natural hazards and for planning of risk assessments and the predictions for that areas. Or you can apply it for the spatial temporal changes and monitoring of spatial temporal changes.
Okay. Okay, Fran, thank you. And yeah, two more questions. Actually, I will ask both the questions together. First one is from Rafiq. That cloudy days without sunny light, is it suitable for photogrammetric survey? So light is the main issue here. And is it about MSS sensors, multispectral scanner sensors, or any kind of sensors? So he's basically asking about the light. And one question is there from Turkey, Sihan. So Sihan is basically asking that there is any software you use to convert DSM to DTM. So these two last questions are there. So please.
Okay, great questions, both of them. Light is of course really important, especially in photogrammetry. In LiDAR, light is not so important because you can basically do a LiDAR survey even in the dark during the night, because the sensor projects its own laser beams which are reflected from the surface. But in case of photogrammetry, light is really important. So too much light is not good, and on the other hand, too low light is also not good. So that's why I told you in presentation that maybe the best situation is if you have cloudy days without too much sun, which then makes shadows, but also not too dark days are of course not good. So this can be sometimes an issue, especially in remote areas like the one in which we operated. And you always have to watch the weather channels, just to see what the weather is going to be like, because it happened to us 3 or 4 times that we went on the field work and then just saw that the situation is not good and that we cannot do the mapping at that day. We could do it, but not so accurately. And this is even more important in the case of multispectral sensors, because if you have a large presence of shadows in multispectral sensors, then when you use these images for, let's say, classification of land cover, it can really lead you to false results. It's similar as with the satellite imagery.
Okay.
And the last one was conversion from DSM to DTM. Well, with photogrammetry, I used Geomatica software. They have really good interactive filtering options for filtering of digital surface modeling, creation of digital terrain models. There are even some automated processes, but of course, when you have really highly vegetated areas, it's not so accurate and not so good. In these cases, of course, LiDAR is much better.
Once again. So now we'll go for a quick coffee break for 7 or 8 minutes. But before that, I'd like to introduce.
You're mute, Saidan. You're mute.
I'm so sorry. I'm so sorry. So yes, thank you, friend. Thank you so much for being here. And I'll just request you to stay here for the last 2 lectures also. Please be here. And before going into a very quick coffee break of 7 minutes, maybe 5 to 7 minutes, I'd like to introduce our next speaker, Paraskevi, Dr. Paraskevi Nomiku. Evie, could you please open the camera if it is possible for you?
Yes, of course.
Yes. Hi, how are you?
Hi there.
Yeah. Okay. Paraskevi, Dr. Paraskevi Nomiku, and she's very fondly called as Evie. So Evie is a marine geologist who studies the morphology of underwater volcanoes with extensive experience in the marine volcanic and seafloor extruding processes. And currently she's an associate professor at the Department of Geology and Geoenvironment at the University of Athens. And she has participated in more than 75 oceanographic expeditions that focused on submarine volcanism, landslides, and exploration of seafloor mineral deposits. And she has played a leading role in the evaluation of the potential hazard associated with renewed volcanic activity at Santorini volcano in Greece. I know many of you are very much aware about this place, Santorini, and Paraskevi is basically born and brought up in Santorini. She is from Santorini, so most of her work is concentrated in that region, obviously, and her studies on underwater volcano areas where new earthquakes and deformations have been taking place are very critical to ongoing evaluation of future eruption scenarios. Now, she has also been involved in the study of economically important seafloor mineral deposits within the crater of this submarine volcano of the coast of Santorini, and it is named as Colombo. It is not the capital of Sri Lanka, Colombo, but it sounds similar, the Colombo volcano. And between 2013 and 2018, she was involved in multiple expeditions to the mid-Atlantic reach for mapping the seafloor of ocean core complexes and mapping the offshore volcanoes. Now, she effectively transfers her enthusiasm for seafloor exploration using different innovative technologies to the students through her educational lectures at the university. And we have many lectures of her, many videos of her in the YouTube platform also. And she has created a high-profile role. She is a very high-profile role model for the young women scientists thinking of pursuing careers in geology, geomorphology, and oceanography. A very warm welcome to Evie from our forum. And Evie, we will go for a very short 5-minute break, and we will reach here. And please, participants, grab some coffee, tea, and something others. So Evie will start the presentation straight away in 5 minutes. So the platform is yours, Evie. Thank you
Yes,
so
I
much.
will share my screen and everything will
Yeah.
be ready.
Good
Okay,
to see you
thanks.
after long. Good to see you after long. Yeah.
Okay.
Okay, Evie. Yes, Sadiq, you want to ask something? Sadiq Abu Bakr, you want to ask something?
It's like the audio is off from my side. Is there a problem from my network or from everyone?
No, your audio is on. My audio is off. No. Oh, the audio is fine. Okay.
Okay, thank you.
Okay.
Stephen, can I try to share the presentation just to be ready?
Yeah. 5 minutes is over.
You are mute. You are mute. Again.
Oh, I'm so sorry. So 5 minutes is over. So 5 minutes is over. So you can start your presentation. No problem.
Yeah, I can just share because the presentation has also very large videos. So I will hope, fingers crossed, that everything will be working properly. Okay. So let's.
And Evie, one thing, can I share your email ID after your?
Yes, of course.
Okay.
Of course.
I'll share in the chat box. Okay, I'm just putting my microphone off once again, so you share.
But I cannot find it. A window with tab. Prioritize screen. So I can find my presentation. I can see it in my, but I cannot share it. I have it just in front of me.
Yeah, you previously shared the screen actually.
Yes, I know, but it says Windows tab.
Okay.
Your entire screen, a window or a tab. A window. A window.
A window, but if you say yes, if it is done separately, if you're.
Can you see that now?
No. Yes, it is coming. Yes.
Okay.
Okay. You start, please.
So whenever we are ready, I may start.
Yeah.
Tell me. Okay. So it's that time.
We are ready. Yes.
Okay, so we are ready. Okay, thanks. Okay, thank you so much for the kindly invitation. Some of you, I have seen you in Santorini when we had the field trip in the beautiful island of this spectacular volcanic landscape of Santorini, and we were just around, only on land. But I was trying also to show you some maps of what is happening of the seafloor of Santorini. So this is also the main scopus of my presentation, is to show you how we map the underwater geomorphological features using innovative technology. So as I am I am Nomikou Paraskevi. My friend is calling me Evie. Okay, so I'm an associate professor at the Department of Geology and Environment. I am a marine geologist specialized in the seafloor mapping and also indicate the marine geohazards. So in this presentation, I will try to show you how we are mapping the seafloor and which are the equipment that we use in order to map the seafloor. So the first thing that we need, okay, for sure, is the research vessel. So this science, the marine geology, needs to have lots of money in order to rent the vessel and also to use innovative mapping technologies for the seafloor exploration. So most of the times we are using some system named as multi-beam system in order to map the seafloor, or we may also use side scan sonar system that acquire information about the surface, the texture of the seafloor. Or sometimes we're using also, this is not only the mapping techniques, but also the seafloor exploration. We are using some seismic sources like air guns in order to identify all the stratigraphic layers beneath the seafloor. Okay, so for us, for this lecture, we will be focused only on the seafloor mapping using multi-beam systems, bathymetric systems in general, or also using ROVs, remote operated vehicles, and also AUVs, autonomous vehicles. So, as I said before, the science needs to have lots of money in order to submit proposals for rating some oceanographic vessels. Just for the start, this is the oceanographic vessel, the Greek one from HCMR. These are some other vessels. And also you need to use innovative technologies like submersibles, for example. You may imagine that this submersible has the dimensions of a very small car, and you will be with the pilot, and you can explore the sea bottom using the submersible. But the submersible is operated using batteries, so the time, the duration of the exploration depends on the duration of the batteries, and most of the times are up to 4 hours with the operational depth of 500 meters. The other systems that we use are ROVs, as I said before, remotely operated vehicles. They use it with the electricity, connected with a cable on with the vessel. So you may explore the seafloor as much as you like. Yes.
Sorry to interrupt. Are you on the first slide itself, or
can you repeat? I didn't hear you.
Are you on the first slide itself, or?
I am on the third slide.
No, your slides are not moving.
I'm not moving. Okay.
Yeah, I think
this is number. Can you see number 3 on the right corner?
No, it is the first slide.
This is number 2. Can you see number 2?
No. I think you can do one thing. You can share the entire screen. So.
Okay, I will stop sharing again.
Stop sharing. Yes.
Okay, let me. Okay, so stop sharing again, and then let's go back. Okay, so again, one more try, your entire screen.
Right.
I don't have the right to share. Chrome wants to share the contents of your screen with me to Google.com, but I cannot share it.
May I interrupt? Madam, may I interrupt? You just click on what you see on the screen.
Okay. Yes, okay. I can find it. Thank you so much.
Thank you
so much. Okay, so can you see my screen now?
Yeah. Yes. Yes. So this is the second slide.
This is the second slide. Okay. Yes. Can you see that now?
Yes.
Okay,
yes.
That's good. So these are the equipment that I was discussed just a few minutes ago. Sorry for this technical problem. Okay.
So another thing, could you click on that hide button, hide icon, share?
Hide. Yes. Can you? Is that better now? Perfect. Thank you so much. Thank you so much for your help. Okay, so as I said before, we are using the multi-beam system in order to map the seafloor, and also most of the time you're using the side scan sonar in order to find out the texture of the seafloor. So, for example, this side scan sonar is also very, very useful for underwater archaeology, if you want to see a submerged city or a submerged port. Okay, so this is the third slide. Okay, so I said before that this is the Greek oceanographic vessel, Aegeo, but also these are some other oceanographic vessels from the other countries. And this is the submersible of HCMR Thetis. This is a small car. And of course, these are the ROVs that are connected using a cable, so you may explore. They are not using batteries, so you have the ability to explore the seafloor as much as you like. Okay, so let's go once again back. Okay, so again, this is the AUV, and these are some other equipment. For example, we are using special gas samplers in order to measure the gases that they're releasing, or you are using ocean bottom seismometers in order to dedicate all the earthquakes that occur on the seafloor, or air guns and the other equipment. So why we are exploring the ocean floor? For the very beginning, this is the base of every oceanographic cruise. So we need to know what is happening on the seafloor. We need to recognize the underwater geomorphological features. And this very plain scheme show us which are the main underwater morphological features. And as I know, most of you are focused on the onshore morphology. Let's say if you drain the ocean, okay, and you have the ability to see what is on the seafloor, you will see exactly the same geomorphological features like the one that you are studying on the onshore. Okay, so the most common one, especially with the people that they are focused on the coastal zone, is this continental shelf. This is the continuation of the land offshore. Most of the time, during the time periods, there are some periods that this is below the sea level or after the sea level. And of course, also here is the continental slope in the area that you find lots of canyons, especially at the deepest part of the oceans. You can find the abyssal plains, the basins, and also you can find lots of mountains, but most of the mountains are composed by volcanic rocks. So the peak of the mountains are the small volcanic islands that you can see in the Atlantic Ocean or in the Pacific Ocean or also in the Aegean Sea. The most characteristic underwater geomorphological feature is the mid-ocean ridge. It is very common feature just in the middle of the Atlantic Ocean. Okay, consists of many peaks along both sides of a central valley. So the model is coming out from this valley. And of course, another morphological characteristics is the trench. The trench is exactly the same. It is a basin, but the basin with a very narrow, steep slopes, with the deepest part also in Earth is almost 11 kilometers in Mariana Trench. So we are mapping the seafloor for scientific purposes. Okay, so this is a very small video. If you drain the ocean, you can see that the topography is in total has exactly the same characteristics. In the areas that you have very abrupt slopes onshore, you have exactly the same abrupt slopes also on the seafloor. Okay, this is the continental slope, and again, this is just in the middle of the Atlantic Ocean. This is the mid-ocean ridge, as you can see here, just in the middle of the Atlantic Ocean. Okay, so it's a very huge line. And also this is the part of the basins, and these areas are passive ones. So you have all the activity in this mid-ocean ridge, but nothing is happening at the eastern part of America or at the western part of Africa. Again, this is the Mariana Trench, the deepest part of Earth, 11 kilometers deep, okay, 10.9. And of course, this is the East Pacific rise at the eastern, the northeastern part of the Pacific Ocean. This is the fastest spreading crust, almost 14 centimeters per year. Okay, so this is for our science. So we need to map the seafloor just to identify all the underwater geomorphological regions. But for what reason? For us, that we are studying the seafloor topography, we need to know the marine geohazards. Okay, so knowing the depth, also the shape, and the type of the seafloor bathymetry and its hydroacoustic backscatter, that means the texture, okay, of the sea bottom, is very fundamental in order to understand the geomorphology and the habitats, the ocean circulation, the tides, the tsunami forecasting, the fishing resources, the sediment transport, the bottom currents. But for us, it's very important to understand the underwater geohazard. That means the marine geohazards. And the main marine geohazard, especially close to the coastal zones, are huge submarine landslides or the canyons. So you need to be extra careful if you have a port very close to the submarine canyon. Or what about the submarine volcanoes? So maybe suddenly you can have a submarine eruption, and the eruption can trigger a tsunami. And of course, in the Aegean Sea, and I will show you some examples later, in the Aegean Sea, we have lots of underwater active fault zones that can be activated, and we have large earthquakes in the Aegean Sea and also in the Ionian Sea. So all of these geohazards, such as the underwater culture, and of course you need to know about the seafloor topography in order to identify underwater cultural heritage like submerged ports or submerged cities or shipwrecks or artifacts. Okay, and of course if you have, you need to know the topography in order to avoid, okay, to pass, for example, a cable and cross a very huge landslide. So you're going to have damages on the cables. So all the areas, as I said before, when I show you the video, they are not so active. Okay, so there are some specific target groups, specific areas that you can have marine geohazards. These areas are the subduction margins, like the one that we are in Greece, because we have the area that the Africa subducts below the European plate. So in the subduction margins, you have large earthquakes, you have submarine landslides, you have eruption from the volcanoes, debris flows, tsunamis, and methane emissions. Or in the area that you have oceanic volcanoes, just in the middle of the Pacific Ocean, or especially the Pacific or the Indian Ocean. And in the passive margin, the passive margins are not active. You cannot have an earthquake or a submarine eruption, okay? But you have the danger of a huge landslide. So the submarine landslides also is a very important marine geohazard. Okay, so how we are mapping the seafloor. For example, if we want to map the seafloor, having a resolution only 1 kilometer, but we need to have all the oceans just in one map, like the one as a global bathymetry map, the one that I show you now, we are using satellite altimeters. Okay, so these satellite altimeters, all the satellites measure sea surface height. This is the sea surface height, and other characteristics of the ocean surface, which are linked to underlying processes and structures. This makes the data useful for understanding the full depth for all the oceans of the global ocean, from the surface down to the seafloor. Okay, so for example, as we said also to the Greek students, you can have a map like this one with 1 kilometer resolution. The cell is 1 kilometer by 1 kilometer, but you cannot see the details of the seafloor topography. But it's very easy to understand that, for example, you can understand that this is the mid-ocean ridge, or these are the basins, okay, or here is the continental shelf. But you cannot find a landslide. You cannot find a submarine volcano. So these are the three ways how to map the seafloor. Okay, the first one is the satellite altimetry, as we said before, with the altitude of 700 or up to 1.400 kilometers. The SWAT width, this is also very important, is 20 kilometers, so you can cover large areas. That's why we produce for the global oceans, the seafloor topography. But unfortunately, the spatial resolution is only 1 kilometer by 1 kilometer. So we use this kind of maps just to indicate the general morphological characteristics of the seafloor. So most of the times, what we are using hull mounted, as we say, multi-beam systems like this one. Okay, so we can map the seafloor, okay, using this type of multi-beam systems with a SWAT width of 5 to 10 kilometers, most of the times are 10 kilometers, but the most important is that you have a resolution of 25 up to 100 meters. So then you can pick an area and you can be focused on the study area and also identifying all the underwater geomorphological features. But now the innovative method that you may map and you can produce microbathymetry maps, the maps that you can also indicate, okay, here is the rock, or here is a very small crater with a diameter of 10 meters or 8 meters. Most of the times we are using AUV, that is underwater vehicle. These are autonomous underwater vehicle. The altitude is about 20 to 9 meters above seafloor, but if you have a general idea of the seafloor topography, so maybe all this AUV can travel above the seafloor for approximately 5 to 6 meters. The SWAT width, look the SWAT width now, so it's less, it's only 200 meters, 50 to 200 meters, so you need to make lots of transects in order to map a specific area, so that means that you need lots of days, lots of time periods, in order to map the whole area. And of course, but the most important is that the spatial resolution is less than 1 meter. So you are using, for example, what we are doing in order to map a larger area, we are using multi-beam systems, and then if we need to map a specific area, because we wanted to see the geomorphological features on the seafloor in very detail, we are using AUV systems, AUV equipment. So once upon a time, or we use single beam systems because we wanted to produce maps only having the single depths. Okay, so this is some maps from hydrographic services. So this is the single beam system, the bathymetric system that most of the cruise vessel is using, okay, because the only thing that they want is to have the depth, all the depth along a specific line of the vessel, okay, so they don't care what is happening, just very close to the vessel. So in single beam systems, an acoustic pulse, you can see that an acoustic pulse is emitting from a transducer. This is a transducer here, and propagated in it's only a single narrow cone of energy directed exactly downward toward the seafloor, providing only a single depth measurement for a location directly beneath the sea, as I said before. So the individual depths of the depth of the seafloor are subsequently contoured to generate bathymetric maps, but not very detailed bathymetric maps. It's very easy to have this kind of maps if you have a sailing boat, okay, because you need to see some specific depths along your transect, but these maps are not useful for our science, for the marine geologists, or especially for the people that need to study the seafloor topography. So in 1950, Maria Trump and Bruce Hazen from the Lamont Geological Observatory creating some floor maps based only on single beam sounding data from the Navy. To tell you the truth, as I said also to my students at the Greek University, we say that oceanography is a very new science because we are using all these innovative technologies that I'm going to show you, but we are using these technologies in a very recent years. So, for example, this is a map that has been created in 1977. It was published in 1977, and it shows only the main underwater geomorphological features. Now that we have AUVs, we have ROVs, we have other equipment, we can study in very detail a specific place of the seafloor. But for us, this map is extremely useful, okay, because we use and we say that, okay, for example, this is the mid-ocean range, this is continental shelf, all these mountains, all these peaks are underwater mountains, and the peak of the sea mounts are the volcanoes, for example, this is Hawaii, or these are the trenches. These are the deepest part, also here, these are the deepest part of the world. Okay, so what we are using nowadays, all the oceanographic vessels, they have multi-beam systems, okay, are used for the seabed mapping, of course. They are sonar sounding systems, also known, we are named them as SWAT systems, and they develop, as I said before, in the early 90s and the 60s for military use. So after the Second World War, all the equipment that was used for mapping the seafloor just for the sake of the submersibles, all this technology transferred to the science. Okay, so the scientists, now that we don't have a war, they use all these different type of the sonars. Okay, so the multi-beam emits sound waves, these are sound waves, in a fan shape, as you can see here, in a fan shape, providing a very wide coverage of the bottom. So you don't collect only single beams of depth, but you can cover a wider area, and you can collect thousands or millions of depths. As also you can also indicate, this picture also indicates the way that we are mapping the seafloor. Okay, so the water depth, this is the water depth, okay, is determined by measuring the double wave transit time of an acoustic wave reflected on the seabed in combination with the sound velocity in the water. We know that the sound velocity in the water is 1,500 meters per second. Okay, so we collect the data, we process the data, and we create beautiful bathymetric maps. But to tell you the truth, it's amazing experience when you are on board and you are just in front of a white screen, completely white screen, and just suddenly you are start mapping the seafloor, and the screen is full of colors, and every color indicates a different depth. So for the multi-beam, we have hundreds of multi-beam echo sounder, and everything depends on the frequency, of the operational depth, of the swath width, and of course the horizontal and vertical resolution. For example, for the large depth, you have large angle, so you may collect as much data as you can in a very fast way. And of course, but this has also a disadvantage. The big footprint, as also you can show it here, it has less resolution. So if you want to map the coastal zone, you need to have a very small footprint in order, as here, for example, 5 meters, the grid cell, in order to collect as much swath data as you can. Okay. Here it is. This is how we collect the data. This is the cell. Okay, so every cell, it has a geographic location. It has coordinates. And of course, it has depth. So it's completely opposite of what is happening on land. We had X, Y, but Z. We have depth, minus 500, minus 100. Okay, falling into the cell. So if the grid cell, the dimensions of the grid cell are small enough, so you may collect as much data as you can. So everything depends on the resolution. But unfortunately, just 10% of the seafloor globally has been mapped using bathymetric data, using multi-beam systems. Okay, that means that it covers roughly 70% of the planet or more, to tell you the truth, more, remain virtually uncharted. So you can see that we have lots of swath data in the Mediterranean Sea, or at the western part of Ireland, or very close to the trenches, the very active areas at the western part of North America and also in the South America. But for example, we don't have lots of data in the Indian Ocean, or we don't have lots of data in the South Atlantic Oceans. So these are the public multi-beam data. Okay, so you can, there are some open sources, databases that you can download the data and you can process the data, and also you can create maps. But fortunately, there is the Seabed 2030 project. Okay, this is the project that all the countries decide that, of course, it's very important to map as much as we can the seafloor of the oceans. So they forced all the research institutes and also the academic institutes, and they give them money to start having more oceanographic cruises. So we believe and we think that in 2030 we will have as much area as we can having the seafloor topography. And this is very, very also important. Okay, focus only in the Mediterranean Sea, and also for the European countries, there is the EMODNet open data base. Okay, so if you go there, the new release is not September, it's December 2020. Okay, so in this area, in this EMODNet data, you may download not the swath data, but the grid files. Okay, and you may, for example, here in the GNC, you have lots of boxes, and you can download the grid file, and you may create some beautiful bathymetric maps with a resolution of 115. So it's very, you are very satisfied with such a resolution, because you can easily indicate all the seafloor geomorphological features. For example, for us, our group has downloaded all the grid files from EMODNet. So this is Greece. Okay, this is the Aegean Sea, this is the Ionian Sea. This is the deepest part of the Mediterranean Sea. The deepest part is 5,200 meters. And this is the synthetic topographic map, using also on land from data from the satellites, and also offshore data from the EMODNet. And also for us, this is an exercise for the master students of oceanography. So they produce this type of maps. And then the students, after the first semester, they try to indicate all the underwater geomorphological feature. For us, that means that they need to find active fault zones. Okay, so the fault zones or basins, the flat areas of the basins, like this one, like this one, like this is the Icarian Basin, or this is the Cretan Basin, for example, or maybe you can find some landslides, or this is the Corinth Gulf Basin, and of course you can find the trenches at the southern part of Crete, and of course at the southern part of Peloponnese. And of course, if we will be focused in the Hellenic volcanic arc, for us another marine geohazard is that except of the on-land volcanoes, we have lots of offshore volcanoes. Hopefully, all of them are inactive, except of Colombo, except of the volcano at the northeastern part of Santorini. I will show you some maps. And then you may play with the morphology, because the volcanic morphology is more peculiar, has a lots of different structure of the volcanic domes, craters, cones, okay, lava dikes, and whatever. Okay, so why we are using multi-beam system? For example, this is an example from Galapagos Islands. Okay, the top picture is with a resolution of almost 1 kilometer. Okay, so in this picture, you can say, okay, here maybe there is a basin, and we know that this is an underwater mountain. But if you need to indicate the underwater geomorphological features, you need to have a multi-beam system. This is 20-meter resolution. Okay, this is a huge difference. And you can see that you don't have only one single underwater mountain, but you have lots of small hills, and the basin is here, okay, or here's a small channel, okay. So the difference is it's big enough, okay. So you need to have multi-beam systems rather than you use a satellites. Of course, when you are doing the acquisition, when you are obtaining the SWOT data, you need to follow some specific rules. For example, you need to take into account the motion of the vessel. So you need to correct some specific numbers on your screen. So the acquisition is extremely important, because if you collect wrong data, you will not have the chance to process the data and create very nice maps. And also you need to have the sound velocity profiles. So you need to know the velocity of the sound towards to the depth. Otherwise, you may create some maps that they are not correct. That's why we are doing CDD in order to have sound velocity. And of course, we are using navigation systems. We are using GPS, okay, with the satellites. For example, this is 24 up to 87 satellites. Why? Because in each map, each pixel of the SWOT maps, it has coordinates and also it has depth. So it is unbelievable if you are okay, and oceanographic cruise without the GPS system. You cannot do that. And of course, this is some short screens from the computers, from the laptops that we have when we are doing the acquisition. Okay, and then we are taking the data and we start processing the data. Okay, so how we collect this wet data? As I said before, we are following some specific parallel transect. Okay, the width of the transects is more when the depth is larger, when you have deep waters, but you need to do lots of transects, parallel transects, when you have very shallow waters. But to tell you the truth, all the captains in the oceanographic vessels, they know how to map the seafloor, and most of the times they don't need any specific lines to show them. So they follow the line, and they know that you need to overlap the lines in order to collect more precisely all the data that you need. Okay, so you collect, for sure you need a vessel. Okay, you're using multi-beam systems. Of course, you are using acquisition, but then we are using, most of the times we are using the EBI system. This is the open software, so it's a free software in order to process the data. But of course, it's not only just click one button and then suddenly you have a very nice map just in front of your screen. No, it's a time-consuming period Okay, it's a time-consuming procedure because you need to clean the data, to filter the data, to interact the cleaning, and then you need to process the data and create the grid. For example, this is an example that, okay, we collect very strange sound velocity profiles, but we need to correct and delete all the wrong beams. And then that was the first data, the raw data. And then this is the basing after the process data, using the process data. Okay, so it's not so simple. You don't, okay, let's rent a vessel, just open the system, okay, turn on the system and just collect the data and create a map. No, you need first to process the data. Okay, so these are the different methods how we clean the data using, for example, 3D models or using also cross-section. For example, all these beams are wrong depths, so you need to delete them in order to have a very precisely seafloor topography. And when you are doing this, then you may create maps like this one. This map is around Santorini. This is Santorini volcano. For us, it's a supermarket of natural disasters because especially on the seafloor, we have so many marine geohazards. So it was extremely important for us to map the seafloor. Okay, for example, let's be focused on Santorini. This is Santorini caldera. You can see the three basins of Santorini caldera, but outside the caldera, especially on the northeastern part, you have lots of active fault zones. For example, this is Amorgos fault zone that has been activated in 1956, giving an earthquake of 7.8 Richter. Okay, or you can find some landslides. Here there are some landslides, or around Santorini caldera, there are lots of landslides. Or also you can have lots of volcanic cones. Yes? No. Okay. Then if you have a seafloor topography, okay, can you hear me? Yes. I can hear a noise. Okay, so if you have a seafloor topography here, for example, you can indicate and you can draw some lines. For example, all these black lines are active fault zones. Or also all these orange lines are the landslides. All these red circles are the submarine volcanoes. Sayada, I can hear a noise in my microphone. Can you hear the voice, the noise?
Yes. Shantanu Samanto, please mute yourself. I cannot mute you. Shantanu Samanto, please mute yourself. Otherwise, I may. Shantanu, please mute yourself.
I think he's not here.
I think so. If he just a moment.
After logging in, he has left, I think.
Yes. Kapil, please. It's mute. Remove or mute. Okay. So we had to remove.
Okay.
Okay. Fine. You carry on.
Okay. Thanks. Okay. Thanks a lot. Okay. For example, this is a seafloor topography. This is a very, very interesting and extremely active area for us. This is at the northeastern part of Santorini. Okay. So here on this map, you can see large landslides. Okay, this is the Santorini Amorgos fault zone, but you can dedicate all this huge large site with a slope of almost 35%. With the landslide toe has a slope of almost 13%. You can see also the topographic profile. The topography is exactly the same when you have the landslides also onshore, but it is very important for us to map the area that you have active fault zone and to see along this fault zone if you have landslides, because the landslides can trigger tsunami. Okay, or also here in Samos, this is the Samos Island at the northern part of Aegean Sea. We mapped this area just a year ago, okay, because this fault zone has been activated with an earthquake of 7.6.7. We had lots of damages in Samos. Unfortunately, 2 young people were killed. And that was the first time that this area has been mapped. So you can see here a very nice basin. This is the active fault zone, but you can see that the northern part of Samo, okay, you have lots of abrupt slopes and lots of canyons, and the most impressive underwater geomorphological feature was the canyon. We found 2 canyons just at the northern part of Furni. These are Furni Islands. Okay, you can see the morphology, the extremely impressive morphology of the canyons. Here are the 2 canyons. We didn't know, and this is another fault zone, so we didn't know that the seafloor topography in the area very close to Samos was so much complicated. Due to the fact that we had the very large earthquake, we went there using the Greek hydrographic vessel, okay, Nautilus, and we mapped the area very precisely using a grid interval of 15 meters, 15 meters, okay. Also, using 3D models, we create, you can see that this is the fault that has been activated, but also it's very impressive that you may distinguish all of the canyons. So we have the activation of the fault zones, but also we have lots of landslides. And we know that there was a small tsunami with a height of almost 1 meter that was flooded all the northern part of Samos. And here, this area, we do believe that this area is composed by volcanic rocks, but we wanted also to investigate more. Okay, so this is the seafloor topography at the northern part of Samos. So one marine geohazard, very important, and there are some marine geologists that they are focused only on the marine geohazards, on submarine landslides, is the area that you can find slumps, or these are the scarps or landslides, and try to find out what is the volume of the collapsed material, okay? Because it is very important to know where are exactly the submarine landslides, especially when they are very close to the coastal zone. So, as we written here, is one of the main agents through which sediments are transferred across the continental slope to the deep ocean. The ubiquitous feature of submarine slopes in all geological settings and at all water depths, this is also very important. You can find huge landslides in the active margins, but also in the passive margins. Okay, so no matter if this area has prompted a lot of earthquakes, you can have landslides also in the passive margins. Hazards related to such landslides range from destruction of offshore facilities to collapse of coastal facilities and the generation, of course, we're all afraid about the tsunamis. Or also, it's very important to map the seafloor near very huge and large volcanoes like Etna. So Etna, we all know that it's a very active volcano, and we have several volcanic eruptions every year. Okay, and also they map the seafloor at the eastern part of Etna because also they are afraid of the large landslides that can be triggered by earthquakes. As I said before, this is Samos, so this is a very detailed bathymetric map at the western part of Samos. You can see how beautiful, how impressive is the seafloor topography. You may draw, okay, you can take your pencil and you can draw, okay, this is the channel of the canyon. So you transfer the sediments from the southern part to the northern part, following this line. Okay, and also, again, I can hear noise.
Keshav Mondal, please mute yourself. Keshav Mondal, please mute yourself. Okay, please handle this. Be sorry for the interruption once again.
No,
okay,
okay.
He has muted. Okay.
Okay, thanks. So you can see all the small rivers, underwater rivers. So you can see the canyon, okay, also here and here. And also we have found some terraces, okay, like the terraces that we have on land. You can find some flat terraces here. That was the first one. And some million years ago, this was land for sure. And also the second terrace, and this is the third terrace. And just to let you know, because we had a cruise just a month ago, we were on board with biologists. And the biologists asked me why they found lots of mammals, okay, lots of sea mammals, like dolphins, only in the area, the northern part of Samos, of Furni, just in this area. And I told them that for us, it was very easy to answer because we know the existence of these canyons. So these canyons, okay, so the dolphins, they found lots of dolphins in these areas because the dolphins found food, okay, concentrated in a specific geomorphological feature, that means in specific canyons. Again, this is also another canyon, underwater canyon in Sicily, between Sicily and Calabria, and there was a huge earthquake, if I remember well, in 1918. So there was, due to the large landslide, we had lots of damages in the harbor and also in the port. So it's extremely important to map the region, the specific part of the coastal zone, and also on the sea bottom, and indicate the dimensions and the geometry of the canyons. Okay, in order to be sure that you are going to have a port or a harbor, not in a place very close to the canyon. What else we are using? We are using Google Earth Maps. So we upload the seafloor topography. Okay, so drain the ocean. And also, you may use the onshore topography. So it's very simple to understand the whole topography of the planet, of the specific area, if you have onshore and offshore data, because, for example, you may draw a river from the top of the mountain, okay, and then you continue also on the seafloor. The river doesn't stop here, just doesn't stop on the coastline. It continues also on the seafloor. So it's very nice to study, especially the coastal zone or the places like the Aegean Sea, that you have lots of islands, okay? And you are not just in the middle of the Pacific Ocean or in the middle of nowhere, okay? To have also onshore topography and offshore topography. And what else we have done for Santorini? We're using only the seafloor topography, and we indicate using planetary mapping and methods, of course. The offshore, we produce offshore geomorphological maps. So we indicate all the fault zones or the landslides. These are the fault zones, the red lines. The landslides are in red, okay? Having also only the swath data, and try to compare and try to map and distinguish the different geomorphological, underwater geomorphological structures. These type of maps are very useful because these are the types of maps that the NASA is used for the planetary geology in order to produce maps from Mars, for example. Okay, and the only thing that you have is topography. Okay, and these maps are very also crucial for the civil protection agencies. For example, here we explore the area of this western part of Costa Rica in the Pacific Ocean. You can see this is an example of a huge landslide in an area very close to Costa Rica. Also here you can see the canyons. We mapped this area, this huge landslide, and also we found another landslide just at the western part of here. Here is the basin. Okay, so you may play and you may upload the data in a specific software, okay, and create this. We use ArcGIS, and you may create some 3D models of the area. Just at the top of this landslide, using specific multi-beam system, analyzing also the water depth, we found cold ships. These are the gases that they are coming out, methane, that they are coming out of the cold ships. Again, if you use the backscatter, okay, of the swath data, you may also produce this type of maps. This has been published very recently, okay, and we indicate all these different morphological structure of the landslide, or here are some canyons, and also all these yellow dots, the black dots. These are the dots that we believe that they are cold ships, producing methane, giving methane, and we dive there using ROVs, okay, and we found, okay, the exact areas that they were degassing. Okay, so we map the area with a specific multi-beam system, also using the water column, and we find out the specific areas that they are cold ships, okay, and of course they collect samples and they measure the gases of the area, cold ships, okay, the temperature there is very, very low. Okay, so the other system that we use, the unique equipment, is the AUV, okay, these are unnamed robotic craft which can autonomously survey the ocean floor along a pre-programmed course, okay, the advantage of these AUVs is that they can travel very close to the sea bottom, so you may collect data with the highest resolution, and also during also this COVID period, unfortunately COVID period, so the big companies, they produce ASV. These are also some sea surface vehicles. Okay, so you program the vehicle and you leave it alone, and you can have swath data from a specific area without raiding a research vessel. Okay, so you can see this is the route, specific route of the AUV, like the Curiosity rover of NASA that goes on Mars. Okay, and of course, all the AUVs, they follow specific transects, but they can cover a small area because of the swath width. The swath width is only 20 up to 100 meters. And of course, of the batteries, all these autonomous vehicles, they are operated with batteries. The batteries, the duration of the batteries is almost 12 hours. So most of the times that we have an AUV survey, we leave the AUV during the night time, for example, 7 o'clock in the evening. It maps the area, and then it comes on the sea surface, and then you collect the data. For example, this is the ABs that we use just in 2013 because we wanted to map a part of the mid-ocean reach. This is very heavy, but if you want to map the coastal zone, you may use smaller AUVs like the Rona AUV, but the operational depth is only 500 meters. This AUV can go up to 4,000 meters. But AUVs, okay, it's not only for mapping. This is the main reason that we use the AUV, but also AUVs are capable of carrying a variety of sensor payloads relevant to marine geoscience, including geophysical instruments like SSS, like magnetometer, like side scan sonar, or geochemical instruments like electrochemical redox sensor, or seafloor imaging tools like high-resolution all multispectral cameras, and of course, oceanographic instruments like CDD. So you may use the AUV, okay, also with a side scan sonar or with a magnetometer in order to map the magnetic anomalies of the seafloor, or specific cameras that you can produce thousands of photos and create photomosaic for the habitat mapping. For example, here is the deployment of an AUV. Okay, we are on board Pakuapa, the French vessel, just in the middle of ocean of the Atlantic Ocean. This AUV is very heavy, so you need to deploy the AUV having specific equipment. Okay, so also it's important to have a specific vessel. Okay, and run. Okay, so this is the AUV, but also here you can see that we have also two magnetometers. Okay, so they leave it. This is turn it off, okay, the cable, and it mapped the oceanic floor for 12 hours. Okay, so this is the type. So the use of the AUV is to map the seafloor, but also you may map a shipwreck, for example, because the resolution is less than 1 meter. The resolution is centimeters, for example, but you need to have plenty of time and, to tell you the truth, plenty of money, okay? Because, for example, just mapping the seafloor of axial seamount, a very active volcano just at the western part of the North America, you need 1, 2, 3, 4, 5, 6, 7, 8, 9 transects, 9 dives. 9 dives, that means 9 days, okay? As we said about the resolution, this is the 20-meter resolution of this specific area in the Pacific Ocean, but this is 1 meter resolution. This is a part of the volcano. We know, okay, that this is a lava flow, but when you have 1 meter resolution, you can easily recognize the recent lava flows here, as you can see, or here. This is 1 meter resolution, so you can see everything 1 meter by 1 meter, all the rocks. So we went there in 2013. We map the ocean core complexes just in the mid-ocean reach, and we were focusing these areas because we wanted to find black smokers. So we used AUV, okay, only in specific parts of the ocean floor. Okay, so we map in very detail all the ocean core complexes, and we try to make some targets. So we can see that these cycles, okay, these targets are black smokers. Okay, the resolution was 1 meter. What else we did? We use a thermometer. So we find out that during these transects, the temperature there close to these cycles are higher. And we dived there with the ROV, and hopefully we found 2 unknown black smokers. And of course, we collected then lots of, with the ROV, we collected lots of samples. Again, in this area in California Bay, they used, swath bathymetry, but they wanted to analyze the seafloor topography along the canyon because they were afraid of the earthquakes and landslides, and that's why they used AUV, and you can see the topography. You can see the boulders of rocks that they are sliding down, or you can see the ripples here, the ripples of the seafloor. Okay, so it's very important to use AUV, but only, as I said before, in specific areas, okay, because of the swath width. So we used the AUV in Santorini, because the main goal was to map the Santorini caldera and also Colombo volcano. So this is the better resolution map of Colombo volcano. This is the very active, the most active submarine volcano that we have in the Eastern Mediterranean in total, close to just 7 kilometers far away from Santorini. So you can understand that it's also very important for us. We use seven different AUV dives in order to collect data and to have this type of resolution using 2 meter resolution. But the result is impressive because we found large rhyolite pumice just at the northeastern part of Colombo. And also we have found lots of scarps, like ridges. We believe that this type of scarps of the seafloor topography very close to Colombo, they are remnants of older calderas. And of course, we create slope maps. As you can easily see, all the inner caldera walls are very abrupt with slope values up to 90 degrees. And also all the external slopes of the volcanic domes have very, very, very high slope values. The rest of the area has medium or very low slope values. What is very impressive, and we are we will be working on that the next year, is we want to create another water geological map, because now we have the 2 meter grid resolution, but also we have lots of ROV transect, we have lots of photos and videos from ROV exploration, and we understand that all this smooth surface, even though the surface is vertical, okay, the slope is vertical, but the smooth surface is composed by pumice. This is the pumice that has been produced by the 6050 eruption of Colombo volcano, like this one. And all these roughy, very abrupt underwater geomorphological features are composed by lavas. So this is lava, and also these are the lava domes or lava dikes. So as you can see, when you have very detailed seafloor topography, and also you have ROV photos and videos, you may produce an underwater geological map. And this is something that we will do in the near future. And of course, this is the active hydrothermal vent field. In this area, we have found more than 120 chimneys that they are degassing, and I will show you a small video on that. And again, we dived within the caldera, because in this area we have found lots of landslides. And even though this map was great for geodynamic point of view, it doesn't have lots of details. So we have been concentrated here at the northern part of Santorini caldera, and we mapped the area using AUV, and you can see the impressive small canyons, but also the small scarps of the landslides. Okay, and also here we dived there with the ROV, and we found some small pools full of methane. Also, the other impressive part of Santorini caldera are the underwater, as I said before, the underwater lavas, and these are the lava domes, the lava craters. Okay, so This is now when we need to focus on the onshore topography, near-shore topography, because, okay, we rent an oceanographic vessel, we use multi-beam systems in order to map the seafloor topography far away from the coastline. Okay, so we have offshore data. Also, we have near-shore data. What is happening? What is between the depth of 0, okay, the coastline, and the depth of up to 50 or 40 meters? This is the crucial coastal zone. So we need to have near-shore data. So most of the times, okay, we are using drones, and if we wanted to use LiDAR bathymetry, airborne LiDAR bathymetry, this is extremely expensive. Okay, so we use drone, and we also use some specific cameras in order to collect data. And of course, aerial imaging processed by structure from motion. But the near-shore elevation data, you need to have you have some limits. Okay, so the water column quality is the most significant limitation for the drone survey. It's very easy to identify the water depth in the area that you have very pure water, okay, clean water, but it's very difficult to define the depth in the area very close to delta of rivers, for example. It's impossible. And of course, the type of coast, the rocky and the depositional, strictly affect the methods and the techniques of elevation data in the collection of the nearshore. And of course, what are the limits? The nearshore zone must be gently sloping or not too steep. The water transparency must be very, very high. The significant water movement it is absolutely right not to have no waves. You don't need to have no waves and no sun reflection. So when we are doing, we collect data using the drones, the coastal area, okay, we wake up very early in the morning, 5 o'clock in the morning, or you use the drone survey in the late afternoon in order to avoid the sun reflection, the reflection of the sea surface. So in this paper, they used the drone survey at the eastern part of Milos. This is the Milos volcano. This part, Paleochori, is very active, hydrothermally very active. There are lots of holes that they are degassing at the depths of 3 up to 50 meters or more. And they used drone survey in order to map up to the water depth of 35 meters and identify the bacterial maps and the area that they are degassing. As the colleague just in the previous talk said about the drone survey, okay, also here we use the underwater photogrammetry. We use AUV and ROVs, robots, in order to collect millions of photos and create a photomosaic. So underwater 3D reconstruction techniques such as photogrammetry are among the latest of these advancements, which has primarily utilized for seafloor habitat characterization, for example, for corals or Posidonia, of course for bathymetry mapping, marine environment inspections, and of course archaeological surveys. So for us, we use, for the coastal zone, we use very light AUV, not the big one that you need a vessel to deploy them, okay, but we use light AUV that you can, we use that from the coastal zone and we leave it and they can map the seafloor. And also we map the seafloor in Paleochoria, the southern part of Milos. Here you can see what is happening on the seafloor because we wanted to create a very nice, a very detailed photomosaic using not a drone, but AUV, this type of AUV, just to indicate where are the bacterial maps, where are the zones that they are degassing. Okay, so this is AUV. Okay, and of course, we created this type of maps. Okay, this map has lots of accuracy, okay, especially this area that we are using the photomosaic also. Okay, those, for example, the white areas are bacterial maps and the other areas are sediments, and we produce different types of maps. Okay, so we use ROV for exploration. We use these light ROVs connected by cables, and also have some batteries in order to map the seafloor structure very close to the coastal zone, in order to avoid to rent vessels. Okay, because to rent a vessel needs to have lots of money. So this is the ROV that we have. The operational depth is 100 meters, and now we will have another ROV with operational depth using optical cable with ROV with operational depth of 500 meters. So the ROV is like another water drone. Okay, so but it's much more difficult to obtain specific transects. Okay, because you cannot see them. You cannot see the ROV. So the experienced ROV pilots, they try to collect data following parallel transect and then collect the data and produce a photomosaic. This is, for example, a 3D representation of the raster patterns of the cameras. All the ROVs have camera. So we use this ROV also for educational reasons. This is the ROV that we have. This is the property of Laboratory of Physical Geography at the University of Athens. It's very, very light, so you don't need to use a vessel. Okay, this is the lesson that we had with the students, how they use the ROV, and it's very easy to use it. It is connected with a cable. Okay, and also we use the drone just to have data both from the ROV and from the drone to map the coastal zone, and you can see how easy you can carry the ROV. We had a specific area, so the ROV will follow specific transects. Okay, here is how we would deploy the ROV. Okay, the most impressive part is also that the ROV is exploring the seafloor, but you can see the seafloor topography just in front of your screen, in front of your laptop, and then you may follow the lines. Here is one of the videos. This is the real-time seafloor exploration. Okay, they follow specific lines, for example. Okay, so this is ROV explanation. Let's move. Okay, so they follow specific raster partners. Okay, the transects. Then you collect the data, collect the videos, and using specific software like Agisoft, and you may create a photomosaic. Also, we use this ROV for the marine geoarchaeology. This is EGINA in September 2019 and also 2021, because we wanted to map the submerged port, and the depth there was almost 45 meters, not here, but here. So we used a Zodiac, and we went just at the top of this structure, and we dived there with the ROV, and we mapped the seafloor much more easier rather than to use to have a diver there. Okay, that was 45 meters. And of course, we have the large ROVs, the ROVs that we use in the seafloor exploration on board oceanographic vessels, and they have everything inside. They have cameras, they have multi-beam systems, they can take a sample, they can measure, for example, the gases, the temperature, they have cameras. So you may have multispectral cameras, all RGB cameras, and you collect thousands of photos. This is a photomosaics at the inner part of the Santorini caldera, and create photomosaic just to identify the geomorphological features. Or this is a multi-beam system. So this ROV was installed, the Blue View multi-beam system, with a resolution of less than 1 meter, 0.5 meters. So you may create a swath map in a specific area. This is the vent field of Colombo, but also you may use cameras to collect photos and create a photomosaic. For example, these are the white bacterial mats, and these are the chimneys of Colombo volcano. And just for the result, we produce the high-resolution bathymetric map of the seafloor of Colombo, especially on the hydrothermal vent field. And this is a video of what is happening on the seafloor of Colombo. These are chimneys that they are degassing. All these gases are pure CO2. And all these geomorphological features, okay, are dotted here as small dots. Here, all these circle lines are chimneys. Okay, what else? We use the ROVs, the photomosaic of the ROVs. For example, here is a very small island in Caribbean island. This is Lechant. Okay, and in 2004 we had a huge earthquake. So we use ROV in order to produce photomosaic, because we wanted to see the offset of the active fault zone. It's very important to know the offsets and to have such a large earthquake. Okay, so what else? So I think this is the last. Okay, I am on time. Okay, so this is the last slide, and this is how we map the seafloor. And the most important thing is that nowadays we are using not only the multi-beam system, but we are using also AUVs and ROVs, using high-resolution systems in order to map the seafloor with a resolution of less than 1 meter, and of course using different types of cameras in order to produce photomosaic, not only having difficulties in a very inner abrupt slopes, but also for us it's very important to know the offset, okay, of the marine active fault zone that can trigger earthquakes or tsunami and may produce large disaster, especially on the coastal zone. And as all geologists say, you never know what you will find while exploring the seafloor. So this is Greek word, σας ευχαριστώ πολύ. So thank you so much for your attention. And I'm here for every question, knowing that you are not expert on the seafloor mapping. And I was trying just in few slides to show you what we are doing on the seafloor exploration. Thank you so much. Stop sharing, stop presenting. Yes, okay, stop presenting.
Yeah, you stop presenting.
Yes, okay, that's good.
Okay, so thank you, Evie. Thank you, Evie, for your excellent presentation. And first and foremost, I would like to say that with this kind of enthusiasm, I mean, I will never be able to match you. I mean, it is very difficult in this medium to speak in front of mute audience with whom you are not directly interacting and have such kind of, energy to deliver.
Yeah, because we love our work. This is the most important thing. If you love your work, you pass your enthusiasm, especially to the young people, and this is very important for the educational purposes.
Absolutely. I have seen you in the field, and I must say that your enthusiasm is infectious.
Thank you so much.
Okay. Yes, the questions are started to pour in the message box. Devashree, why don't you ask the question directly by opening your video? Devashree, please.
I haven't really asked a question, but I would love to use this opportunity to congratulate you on this, outstanding and engrossing presentation. I think I would go so far as to say that after seeing the presentation, I think it would take me some time to even frame a question. It was wonderfully engrossing, honestly. Excellent and exhaustive level of work that we have been fortunate enough to be exposed to through this medium. Thank you very much.
Thank you so much. Thank you so much. Thank you.
Thank you, Devashree, and I'm sure many questions will be there. So yes, Ankita Pal, she's also saying thanks, ma'am, for your excellent presentation. You just don't merely thank her; you ask her questions. I mean, she's always ready for it. Asma Aichi from Morocco, you please go ahead. Yes, Rashmi, please ask this.
Yes, ma'am. Actually, first I'm really happy to see your this enthusiasm, ma'am. Actually, in your all presentation, you are talking more about submarine volcanics and all. Actually, ma'am, I am working more on fluvial. But I have a doubt if it is, for example, if I have to study about delta, the extent of delta. And that delta is tectonically active. Okay, because of some there are some already faults are all there. So how I can study it in detail? Yes, ma'am.
This is a very, very, very good question. And as I said before, just in front of the rivers, because of the massive sediments, okay, you cannot not easily distinguish the seafloor topography. For example, you cannot use drones or cameras. The only thing that you can do, but also it's very, very difficult to map the seafloor topography, is to use specific ROVs or AUVs and just start to collect data very close to the sea bottom. Okay, but most of the parts you will find only sediments. This is the area that for us also, it's very difficult to map. So because of the sediments, it's extremely very difficult to map. Okay, you cannot use satellites, you cannot use drones. The only thing that you can use are the ROVs or AUVs. Okay, the AUVs that they can travel very close to the sea bottom. But this question is also very crucial for us to understand what is happening just in front of, for example, Delta Nile. Okay, and they have mapped the Delta Nile and they have found cold ships, but not so close to the Delta Nile, just far away from the Delta. Okay, they have found lots of cold ships. Yes, it's a very crucial area also for us, for the cold ships.
Yes, ma'am. Because of this huge sedimentation, even if you see this Western India, means in India, in the Western India, okay, in that side also it is you can see a huge rift basin, and everyone knows that it is active and it is a rift basin, but nobody knows actually exactly what is happening there.
Yeah,
So
exactly.
in this, is there any other satellite images, or can we adopt any other technique to study this?
Of course, you may also use side scan sonar because you need to identify the texture and also the backscatter of the multi-beam system. For example, the picture or the videos that I show you from Costa Rica, okay, even though it doesn't have any in front of the rivers, okay, but you use the backscatter in order to identify the texture of the seafloor. So this is also another technique that you may use, okay, just in front of the rivers, for sure.
Okay. Okay. Ma'am, can you please share your email ID?
Yes, of course. I think, Sayedan, can you please share my email address? Of course. You're mute. Sayedan, you're mute again. We cannot hear you.
Yeah, I'm having this problem again and again. Forgetting everything. Okay, so the participants, please go ahead and ask the questions. I'm just putting Evie's email ID here in the chat box. You can get the email ID from here. You just copy it.
Hello.
Yes. Orindam, yes, please.
As nobody is asking the question, it's a great presentation from your side, and I'm very happy to see this. That my question is how to characterize the seabed substrates and the ground truth, the multi-beam echo sounder, backscatter data. Like, do you use in your vessel like the sediment grabbler?
Yes, the ground truthing. Yes, most of the time you are using a grabber, and when we are in the Atlantic Ocean, we use also a TV grabber that was more specific equipment, or you may use corings. So, for example, or also you may use the ROVs. This is the ground truthing. Okay, if you map the area with the AUV, like we did in the Mid-Ocean Ridge, and you know that, okay, these are the ocean core complexes. This is the way that we found also the black smokers. And then you dive there with the ROV, this is the ground truthing. And also the way that we will produce the underwater geological map of Colombo is we will follow exactly the same steps. First, we map the area, okay, using multi-beam system or IUV, and then we have the ground truthing for the ROV videos and photos, and we will say that, okay, this morphology, it's very rough because this is the lava dikes, for example, or these are pumice. So you may use ROV, you may use grabbers, okay, sediment grabbers, or you may use cores. You may use corings, okay? You have different types of corings, okay? And this is very important for the underwater geological mapping. It's a very nice question.
Okay.
Okay, thank you so much.
Thank you.
Okay, anyone from outside India? I think Professor Sunil Kumar Dey is here. He was there in that particular field also in 2019, that pre-conference field of RCG Athens. Post-conference.
But I do not have any question. Only I will congratulate you for your beautiful presentation. I was going through this one.
Thank you so much, Professor.
And
Thank you so much.
You have drawn all these bathymetries using this drone. It is beautiful. We have done some work, but using total station, not because we don't have access to drones here.
Yeah, okay. This is also very important for us, for the drones.
Yes,
Thank you so much.
Welcome, welcome.
The people, especially who are working in the coastal environment and volcanic regions. So please come ahead and ask the question, please. Shoheli, you want to ask something? Because Evie is there. You know Evie very well. Anyway, Alessandra Ogbole.
No, but
Oh, yes.
I just want to. Hello.
Yeah, yeah, you are
Hello.
audible.
Am I audible?
Yeah, yeah, absolutely. You are audible.
I just want to thank you for your excellent presentation, Evie. It was nice to hear you from. It was nice to hear from you in Athens, and it is outstanding. Always.
So as always, Evie is very energetic and outstanding. As always.
Hope to see you again in Greece or in India.
Yes.
Yes, this time you come to India.
In Portugal.
Or in Portugal, exactly.
Okay, anyone? I saw one from Nigeria. I think she was there with her cameras open. I don't know. So anyone else? Please. You ask anything about seafloor?
Or you can send me an email so I can ask whatever you like. So no worries about that.
Exactly. We can have time. We have time for 2-3 more questions, I think. So it's only 6:10 India time. So please, participants, please ask the question. Even anyone from outside India, please have some query. If you have some query, ask the question directly to Evie. No.
Maybe they have. They need to drink a cup of tea or coffee. Mohammed, yes.
Mohammed.
Yeah.
Yeah.
Thank you for the nice presentation. And just I came in the middle of it, but I have a quick question about if I can use LiDAR for the seafloor. I know that I can use it for the shallow water very well, but I don't know if it's enough to have the geologic formation or the lithology or the outcrops.
Yeah, okay, this is a very good question. Okay, so using satellites, you may have the depth, the depth points up to 20 or 30 meters, okay, using satellites.
Right.
Okay,
yeah.
That's correct. So you may produce very nice, not very high resolution maps, but very nice swath maps using satellites up to the depth of 20 meters. If you use airborne LiDAR, but this is extremely expensive. Okay, only for one flight, it will cost, I don't know how much money it will cost, thousands of euro. Okay, so you can have and you can collect very good quality swath data up to the depth of 50 or 100 meters, if I remember well. Okay, and also now they are using drones with specific cameras, like multispectral cameras or RGB cameras or with different types of cameras, and they can collect swath data, again, with a depth of 30 or 50 meters, okay? Because the problem, also our problem, is the near shore area. So we cannot use vessels just to approach, to be very close to the coastline. And the other thing that you can do is to use ROV, for example, or small zodiac. For us, when we map the area within the caldera, Santorini caldera, we use a very small zodiac, and we had a multi-beam system. And also now they have the multi-beam system, they have the fan shape not going downwards down, but also having inclined, okay, towards to the slope. So you may collect in this way much more easier the data that you want to collect up to the depth of 30 meters, for example. But the airborne LiDAR is extremely expensive, and even though the quality is very good enough, it's a very expensive sport, as we say. It's very expensive, the mapping.
Yeah. Thank you.
Thank you, Mohammed.
Thank you, Mohammed. And I think someone again has no.
Yeah,
Arindam again. Yes, Arindam.
Yes, I have another question. As nobody is asking again. Like, which one is better, like wide angle or narrow angle for better understanding of the lakes or the sea floor using single beam?
For the lakes?
lakes or the seabed, like using a single beam? Which one is better, wide angle or narrow angle for detailed understanding?
You need to have a very low angle, okay, not a big one for the single beam, okay, single beam. For the multi-beam, if you have the small footprint, you need to collect a lot of data. If you have a large footprint, you will collect more data, but not in a good quality. So if you have a small footprint, okay, so the angle will be very narrow.
Very narrow, yes.
You are going to collect more precisely data.
Yes.
But you will spend more time.
Yeah.
For mapping, okay.
Exactly.
So you will spend more and more time, okay. This is also important, the time consuming.
Okay, thank you very much.
Thanks, Ardham. You are mute again, Sayadan. Mute. We cannot hear you.
Ankita, yes, thank you, Evi. Ankita, why don't you ask the question directly, please? Ankita Tamuli, can submit.
Am I
yep.
audible?
Yeah, you are.
It was such a wonderful treat to listen to you, ma'am, and as I was all day listening to everyone, it was such a wonderful day with you all geographers. First of all, I like to thank.
We lost you.
Yeah, probably there is some connection problem. Anyway, can submarine sensors be introduced for much extensive study? She asked.
Since you have told about the drones, have the submarine sensors have been introduced in the study of seafloor spreading till now?
I didn't hear the question.
Ankita, there are some feedbacks. So you just turn off your audio and you ask the question on behalf of you.
Okay, sir. Okay.
So, Ankita, please turn off. Yes. Can submarine sensors be introduced for an extensive study of seafloor? I mean, it's a general question. Probably she's meant to say throughout the world. Can submarine sensors be introduced for seafloor related studies throughout the world? It is not possible. It's a vast area, but in in general sense, how much feasible is it to introduce?
No, it is feasible. Yeah, that's why we say that we have the this huge global project. They try to map as much as they can all the parts of the oceans. Okay, and of course the spread centers. Okay, the mid-ocean ridges and the trenches are very important for all the marine geologists and of course the marine biologists. Okay, for example, nowadays they will have, not nowadays, but in a month, they are going to have some oceanographic cruises just to map the northern part of the Atlantic Ocean for months and as much as they can. So they will collect SWAT data in order to produce more precisely maps. But of course, they need, as I said before, that you need to have money for that. I think multi-beam hydroacoustics will do that work. So of course, they can do that work. The multi-beam systems can do that work, of course. But you need to have cruises, okay, oceanographic cruises.
Okay, this type of expedition CV, it's not very common in India. I mean, we do have some submarine canyons. In fact, I hail from the Delta region, and near this Bay of Bengal, you must know about Bay of Bengal, this Ganga Brahmaputra Delta region. So we have one submarine canyon. It's called Swatch of No Ground. So I don't think any study like, the kind of equipments you are using, I don't think it is employed in this area. So obviously geologists, geomorphologists, they are working on this area, but I don't think this type of modern things are being employed here. So obviously it is needed. It is needed to map the seafloor in this part of the world also, not only in the Mediterranean or the Atlantic you are working in. So anyway, thanks a lot. I don't think there is any more questions. So I'm asking all the participants for the last time. So
thank you so much.
If you have any query? No, I don't think so. So Evie, thank you very much for your excellent presentation. And we'll now move on to our last presentation, but before that, I think we can take a short break of 10 minutes. And if it is possible for you, you please stay for our last presentation, if it is possible for you.
Okay,
Okay.
thank you so much. Thank you.
Okay.
Bye.
Okay, thank you, Evie. Thank you.
Yeah, after that valedictory function will be there, no?
Yes, after Adolfo's presentation, the valedictory function is there. And
Okay.
also to all the participants, you can share your feedbacks on that particular program. Please, we are very much eager to listen to your feedbacks, whatever, positive or negative. But please be there. We would like to have that valedictory session as short as possible. So it is mostly, the time will be mostly allotted for your feedbacks only. Okay, so there won't be long speeches and all. So please be there. Please don't log out after the last presentation of Adolfo. Okay, now yes, you can wait for another 10 minutes. So when we have, if Adolfo is available, I don't know, I don't think so Adolfo has logged in or not. Adolfo, are you there? I don't think Adolfo has joined. Anyway, I'm waiting for Adolfo. We are waiting for Adolfo to join, and the lecture will start at exactly 6:30. So we are right on time, and we won't waste much time. As soon as he comes, we will start the lecture. So thank you for your patience once again. Please be there, everyone. Within 8 o'clock India time, we are hoping to end this last session. We are already at the fag end of this program. And yes, I told yesterday that you can interact. We will keep this link open for another half an hour, even after this entire session is over, even after the valedictory session is over. So you can interact with each other, share your contacts and all. Okay. Let me check with Adolfo.
ছিলেন, কারণ আপনার সাথে আমি তাকাশি ম্যাডামকে, তাকাশি স্যারকে আমি গুলিয়ে ফেলেছি। তাকাশি স্যার এক্সিকিউটিভ কমিটির মিটিং এর জন্য, এক্সিকিউটিভ কাউন্সিলের মিটিং এর জন্য সকালবেলা সান্তরি থেকে দৌড় মেরেছিলেন। আমার মাথায় ঘুরছে আপনি দৌড় মেরেছিলেন। ঠিক আছে, হ্যাঁ, ওই জন্য আমার টোটালি গুলিয়ে গেছিল। ঠিক আছে, ঠিক আছে, ঠিক আছে, ঠিক আছে, ওকে, হ্যাঁ। হ্যাঁ, ওটা ওটা তো presentation Please send me the link. কে বলতে থাকে? বাইরের প্রোগ্রামে যদি তোমার মেন প্রোগ্রামে এন্ট্রি করতে দেয় না, হচ্ছে কি অন করে দেয়, অন করে দেয়।
Yeah, Adolfo.
Yes. Hi. Good morning.
Hi. You're feeling sleepy?
No, nothing. No. I am ready.
Buenos dias.
Buenos dias.
Anyway, we are just waiting for 2-3 minutes, and many people have temporarily left this space because they have got this 10 minutes of break. So I think they went on to grab some coffee or.
Adolfo, how are you?
Hi, Sunil. Very good, and you?
I am fine.
It's very late around there. No, it's like 6:30 p.m.
Yes.
Okay, not too late.
Yes, it's 6:30 here only.
Okay, here is 7 a.m.
Oh, good.
Just starting the day, so no problem. I'm really fresh.
Yeah. Okay. And we are exhausted.
How are you, Sunil?
I am fine. How are you?
Very good, very good. I returned this year to Costa Rica after the PhD in Geneva.
Okay.
So everything is okay here. Now tropical guy again.
So this, whole life is changing place, changing climate, everything. No, our life is like that. That's why we are geomorphologists now.
Exactly. Now trying to return something to these tropical countries, because we have a lot of methodologies, a lot of knowledge that we can apply to developing and tropical countries. It's important.
Yes. Okay, carry on.
Okay, so I think people are joining. Let them join, and meanwhile, I will give the introduction of the speaker in a formal way. Okay, so Adolfo, Kapil is there, Shubhendu, our co-convener is there, and Kapil, our organizing secretary is there, and many people, obviously, Arindam, Anvesha, all of you.
Hi, everyone.
Yes.
Hello. Good morning.
Hi.
Okay. So here is Adolfo from Costa Rica, our last speaker for this particular event. And Dr. Adolfo Quesada Roman, he's a distinguished researcher of the School of Geography, University of Costa Rica, San Jose. Actually, he's an associate professor there. And his primary research interest is natural hazards, dendrochronology, and geoheritage. And he holds distinct skills in geomorphological fieldwork, especially in the geomorphological hazard monitoring and modeling with special attention on the Costa Rican geomorphology. And his PhD work was actually on dendrochronology, and the thesis title was Deciphering Natural Hazard Histories Based on Tree ring analysis in contrasting tropical ecosystems of Costa Rica. And he was awarded in 2020 for this thesis, and he worked in the University of Geneva as a research scholar, and his advisor was Professor Marcus Stoffel and Juan Antonio Veloz Torres Canovas. And Adolfo, although he was working in Geneva, his primary research interest was in the tropical areas. So many of us, we can relate. I hope from his presentation, many of us, we can relate, because he's a tropical guy, and most of us, we are also residing in the tropical region. And he has published about 100 publications in different scientific journals and books. You can go through his ResearchGate profile also, and his Google Scholar profile also. And he's currently the president of Geomorphologists Association of Costa Rica. And if I'm not wrong, he's also the founder member of that particular organization. And he's most importantly an IAG young geomorphologist, and he participated in the first intensive training program conducted by IAG and EGU that took place in the Indian Himalayas in 2017. In fact, I, myself, Adolfo, and Vittoria, we all were on that particular field in Dehradun. So, on behalf of this Young Geomorphologist Forum, I am formally welcoming you, Adolfo.
Okay, well, Thank you very much.
Yes.
Thank you very much, first of all, for the invitation. For me, I'm very glad to participate in this event. Well, about 4 years ago, I remember I flew from Geneva in Switzerland to India, to New Delhi, and it was a tremendous opportunity and open mind for me, because I completely saw geomorphology completely different. Previously, I knew about geomorphology in Mexico because I did my master thesis in Mexico, and I knew a lot of geomorphology, but not in Costa Rica. We didn't have a lot of information or very good professors in geomorphology. So coming to India and to open my mind, seeing a lot of top researchers and all India stuff, and a lot of friends I made there, opened me the opportunity and my mind to create the Costa Rican Association of Geomorphologists. It was my idea, actually. I brought it to Costa Rica. I gathered all the researchers, and at the end, we could develop this association. So now we are just starting. We are in diapers now, but we're going slowly. But at some point, we will have a young geomorphologist division. We will have we will bring regional conferences. I'm sure about that. But this pandemic year it was completely adverse to us, because we couldn't progress enough during the last and this year. So I hope next year will be better for us. But okay, today let me share my. Let me see. Do you see it?
Not yet.
Not yet. Let me see. Now.
Mostly use Zoom, nah? You guys mostly
Yes.
use Zoom. Yes, yes.
Right now, you see it?
Yes. Yes, we
It's
can.
charging it. Okay. Perfect.
Yeah. You start.
Ignore. Okay. Let me go to the first one. Here. Okay, no problem. Here again. And go here. Okay. Now we have it. So today I bring you this presentation called Natural Hazards Fieldwork in Tropical Environments. Okay, Costa Rica is tropical, obviously, but I wanted to put this in perspective because many of you do not know where Costa Rica is, or you know just little ideas of Costa Rica. Well, I'm an associate professor in the Department of Geography of the University of Costa Rica, and as I told you, I'm the president of the Costa Rican Association of Geomorphologists. First, this is the contents of my presentation. I'm going to present you where's Costa Rica, but not where is Costa Rica located. It's mostly Costa Rica, how is tropical, how the dynamics looks like, and why the country is very dynamic. Which are the common natural hazards? Which are the geomorphological methods I've developed in the last years here in Costa Rica related with natural hazards, and which are those recent studies? First of all, is located in Central America. Is the product of tectonics and volcanism related to the interaction of 5 tectonic plates. The main geomorphic agents are the intense weathering, the 3 types, you know that very well. The water, the ice, gravity, and waves. And you will say, ice, this guy is crazy. No, I'm not crazy. 20,000 years ago, we had glaciers in the top of some mountains, so we have inherited landscapes. Right now, the country is very small. It's 51,000 square kilometers. It's a very small country. It's like the state of many of your countries, or in India especially, or others. But very interestingly, 65% of the population is located in a very small part of the country. That is 14% of the area of the country, and is called Greater Metropolitan Area. So we have a lot of natural hazards concentrated in urban context, and we will see more during this presentation or class. So we have Mexico. You know that from Mexico and go on is North America. We have the Caribbean, we have Central America and South America. So Costa Rica is right here in between the Caribbean Sea and the Pacific Ocean. And there is a complex tectonic around this region. You have around 5 tectonic plates that make up the tectonic framework of this area. In the case of Costa Rica, we have the Cocos Plate, Caribbean Plate, subduction process, and 3 morphotectonic regions. These regions are the magmatic volcanic arc from the Miocene to the Quaternary, 4 arc that is narrow basins going to the Pacific, and wide plains going to the Caribbean. So this is a back arc. So we have these 3 morphotectonic regions that are a very, very good way to have a first picture of your landscape. It's a recommendation I give to you. Integrate tectonic in your geomorphological studies immediately you start, because you have the tectonic framework and immediately you make some units or use previous works units. This is very important in your studies to understand your dynamics. Then obviously the geology of the country in general terms are from volcanic oceanic floor 150 million years ago, from the Cenozoic. In these green parts is the platform of Costa Rica. Let's say that is the platform of Costa Rica, the basement. Then sedimentary rocks around 65 million years ago, the oldest ones. Volcanic rocks from the Miocene 33 to 5 million years ago. And quaternary deposits, no more than 2 million years ago of deposits along the rivers. In terms of geomorphic environments, this is a work I published last year related with geoheritage, geoconservation, and geotourism in Costa Rica. That many of you are interested, I know, in this topic. And the country basically have these geomorphic environments. You have the volcanic ones, the karstic, the green ones, the glacial paleogeographic context, the fluvial, that is the main one because it's a tropical country, it rains a lot, and the coastal environments. And you see them here. I love to promote my country because it's a beautiful country. We depend on tourism. Look, these volcanoes. This is Poás volcano, Irasu volcano, Arenal volcano, very famous, all of them. This is Barba volcano. As you can see, for example, in these 2 pictures are mine. But for example, look, these 2 pictures, how the use of drones, for example, UAV vehicles have developed these beautiful pictures that we can use, for example, in geomorphology for mapping, or we can use them for geoheritage as well. So right now we have this very nice opportunity to create very good papers, very good materials with all the information that we have with drones. So I want to promote this as well. But this volcano Arenal was very active during the last, let's say, 40, 50 years. But suddenly, like 10 years ago, it stopped its activity. But it's one of the most tourist regions of Costa Rica, called La Fortuna, and surround this volcano is called Arenal. This is the Caribbean side of Costa Rica. You have white sand beaches in some parts of the southern Caribbean. Also coastal lagoons, very straight coastal beaches, very active beaches in the Caribbean. And the transition from the mountains to these lowlands and very flatlands are marked by a lot of waterfalls in lava fronts, as you can see here. In the Pacific side, is more dynamic, is more intricate landscape. You have tombolos, for example, this one tombolos this is the most visited national park. It's called Manuel Antonio. This one is they call the whale's tail. As you can see, it seems like it's another tombolo. This is the biggest wetland in the country. It's a delta in the Terra Basierpe Delta, and this is a normal Pacific coast beach in the northern of Costa Rica. You have here the paleoglacial landscapes. This is the highest point of Costa Rica. It's called Cerro Chirripó, 3,820 meters, almost 4,000 meters, as you can see. Glacial lakes, glacial valleys, and some of the this is 2 environments in one, because here is karstic islands created by coral reefs, uplifted by a earthquake in 1991. So now in the common natural hazards part, I have to tell you that the 90% of the disasters in the country between 1970 and 2020, let's say, are landslides and floods, as many tropical countries, and is a tonic in the world, at the end. Floods sum around 60% of the total number of events, and landslides around 30%. There is a very interesting thing that many times in Costa Rica, for example, volcanic and earthquake events are more studied and paid by the government, but they only sum that 10% of the total loss in the country. So this is very interesting. So this is the same thing we saw in a few slides before about the regions in Costa Rica. But very interesting is how the precipitation behave along the year, and we have two different regimes. One is the Pacific, that is bimodal. You have rain at the beginning of April, May, and June. Then the midsummer drought, it's called canicule, or in French, or canicula. Then the top of the rain right now, that is September, October, and November, and then the dry season. In the Caribbean, it rains basically the whole year with a little hiatus in March, let's say. But this hiatus is almost 150 millimeters, so it's a lot of rain at the end. This rain coincides with the total number of historic numbers in 50 years of landslides, for example. September and October, the larger number of landslides, for example, in the historical record. Where are located these hazards, for example, of landslides is located where you have more rain in the country and where you have a lot of more concentration of earthquakes as well. This is a paper that I published in March, last March, and you can see this landslide risk index of Costa Rica, something like that. It was published in International Journal of Disaster Risk Reduction, and you can see how you merge different variables to produce an index that can be used for the municipalities. Landslides are very normal in the country, but many of them are triggered by tropical storms. All the bunch of processes related with tropical cyclones. It can be tropical storms or can be hurricanes. In the terms of floods, that is the biggest process in the country. The same. The larger number of floods in this case are related in September and October, the most rainy months, and in both sides of the country. This is an ongoing work that is right now in revision, and the larger number of floods are normally located in the Pacific, not in the Caribbean, because of some indirect effect of the tropical cyclones that basically pull all the humidity from the Caribbean, from the Pacific. Here is located the tropical convergence zone, the intertropical convergence zone in Costa Rica during July and right now in November. And when you have a tropical cyclone here, they pull all the humidity, they smash over the mountains, and it rains over the Pacific basin, not the Caribbean. It's a very interesting indirect effect of rain. Tropical cyclones, and I'm starting to introduce, is a very intensive process that affect the country. But as you can see, perhaps not at other countries that perhaps all the time the historical tracks mark that are affecting those countries. But in Costa Rica, directly, we only record one example that I'm going to present you in this talk. Recent, let's say, last 30 years events. Huracán is in Spanish, is this hurricane, Huracán Juana in 1988, Cesar in 1996, 2008 it was in the Pacific. It was very rare or weird event. This normally do not happen in the Pacific. Thomas in 2010, as you can see, very far from Costa Rica, almost Jamaica, and La Hispaniola is called this island where Haiti and Dominican Republic can affect indirectly the country. But more recently, in the last 5 years, Otto, it was the first hurricane that crossed directly the country. It was the first one recorded. And in 2017, this one night, it was a tropical storm affected very intensely the country. Why this happened? Normally, these events are located during ENSO events, but the negative ones related with La Nina, more rain. In Costa Rica is related with more rain, as you can see here. The ones I presented you are these ones. Well, this one was 1 year ago. It was Hurricane Eta. This is Central America, Costa Rica, as you can see, impacted. Perhaps you saw in the news 1 year exactly ago. Look, when we have the extremes, the negative extremes of the oceanic Nino index that are related with La Nina, we have bigger hurricanes or bigger tropical cyclones. The ones I presented you before are located in here. Now I'm going to present you the different geomorphological methods I've implemented during the last years, since I'm working geomorphology since 2010, let's say. So 11 years being a geomorphologist. First of all, is the most important tool I think we have to develop as young geomorphologists is the geomorphological mapping. There are a lot of tools. There is right now with the computer, with the GIS, you can make beautiful maps. You only have to continue to follow all the guidelines. You have many guidelines. You have a lot of teachers that can teach you how to make the maps, but you need imagination. You need a little bit of art. The morphological maps are half science and half art. If you make a ugly map, the map do not really represent the processes you want to show in your work. After this, when you do your morphological map, you have three steps. First is the pre-map. No, you make first is a preliminary map. Then you go to the field work, and after that you check and you do the final, the post mapping. So you have a pre-mapping, you have a field work, and a post mapping. This is the three steps in a geomorphological mapping. But the geomorphological field work need several rules, several guidelines that you have to follow. Also, I have applied dendrogeomorphology during my PhD that finished one year ago, kind of. Then right now we are developing all the UAF, the drone flights right now are very, very good for geomorphological assessments. I've been applying hydraulic modeling, and obviously right now a serious study needs statistical modeling or analysis. Geomorphological mapping, for example, this region that I presented you a while ago, it was this lake. You remember that it was like a valley, like a glacial valley. Look, you can see it in a photo and you can see it in your map, as you can see here. You need a very good legend. As you know, there are many, many geomorphological schools, the Russian, the French, the German, the British, the Italian that is very strong as well. And you have to follow those guidelines and make beautiful maps. Perhaps this is not the most beautiful map, but it can be read. That's the idea of the map. And you have to all the time separate the erosive. In this case, only it was glacial landforms. So I separated only in erosive and depositional or accumulative landforms. This was a work that was published in Journal of Maps like more than 2 years ago. The field work. So field work needs time, needs effort, needs planning, and it's very important in the tropics because you access a lot of very difficult accessing areas and you need time. Perhaps you think I'm going to have 15 samples today, and perhaps you got only 5. It's normal because in the tropical environments it's difficult, the field works. You have snakes, you have rivers, you have mountains, you have difficult access areas, so it's normal to have difficulties. For example, this is fieldwork related with dendrochronology. Many of you know about this, the tree rings study. For example, in this case here is in northern Costa Rica. It's a tropical dry forest region, so I wanted to see the climate variability during the last 30 years, let's say. A tree like this one in the tropics is 30 years, imagine that. And for example, in this case, it was more related with dendrogeomorphology, trying to reconstruct peak flows of this river during a tropical cyclone. And this one was the same. I saw that the river reached this area, so I wanted to see if the tree recorded previous impacts of floods. Not here. Also, in geomorphology, we can use the drones. No, the drone flights can be used to model the peak flows. For example, here in this area, Alaar, a volcanic flow impacted in 1963, very close to Irasu volcano. We knew the peak flow of that year, that was 650 cubic meters per second. So we had the drone flight, and we could in the program develop the model to try to see what could happen today in this area. And using the drone, we can see this. We can take oblique photographs, and this looking different DV bridges that was built during the 1960s, that many of them are right now broken. But we can see also informal housing, and we can go from geomorphology, hydrology, and we can go forward to risk assessment. And we saw that over 40 structures of informal housing are located in the impacted region. And we can say to the authorities, look, 200, 500 people will be impacted if something like this happens. So now we can make decisions in the territory. So we go forward more than only say, this is a very nice geomorphological map, or the dynamic is this or that. Recently, I've studied different hurricanes that have impacted Costa Rica. I don't know if by luck or because I really like hurricanes or tropical cyclones, but I think they really impacted the country intensely. As you can see, 5 years ago, this hurricane impacted in 0.4% of the gross domestic product of the country. So it's important. 1 year after, 1.3% of the GDP. So these hurricanes are impacting in huge manner the country. And 1 year ago, and we don't still know how much it was the quote of this hurricane to the country. As you can see, this was Hurricane Otto in 2016, crossing the north of Costa Rica. This hurricane impacted, but first of all, 4 months before, two earthquakes, it's called duplet, that was separated by 15 minutes each other of 5.4 scale, impacted the base of a volcano that is called Miravalles. After 4 months after, Hurricane Otto impacted Costa Rica and crossed Costa Rica, and here you see the 3 volcanoes there. The precipitation, the rainfall, was almost 300 millimeters next to the volcano. The volcano is around here, where I'm marking right now, and you see in the screen. Almost 300 millimeters in only 6 hours when the hurricane was crossing by. By helicopter flights, they saw a lot of debris flows. You can say debris flows, or even large, because they are coming from a volcano. A lot of landslides. I saw, and I numbered 960 landslides over the volcano. And what caught my attention is that in Costa Rica, during this hurricane, 9 people died, but from those 9 people, 8 died in both sides of the volcano, in the lowlands, in the transition from the mountain to the flatlands. So I went to the field like 5 years ago, and we saw how this hurricane impacted that volcano. A lot of landslides that you can see from the bottom. In the field, you can see that the rocks do not have any silt, any clay, so only very coarse materials. And you can see the effect of the woods as an extra element in the formula of risk. And many of these trunks were like missiles affecting the houses, the streets, and the bridges. So it's another element that you can have that you have to consider in any environment. It can be template environments as temperate environments as in tropical environments in any. This is called large wood, and you can search more about that. So I made some maps, and for example, this is the big frame. Look, all the debris flows that impacted here in this area. 4 people died. In this area, 4 people died. Look where it was the epicenter 4 months before, and remember that the hurricane crossed something like that. And around here, we had 960 landslides after this event. So in my analysis, I saw that conformly more close to the volcano than the epicenter you had more density of landslides. This is very interesting. It's a couple effect of earthquake and the rainfall. Just give me a second.
কর্মসূচি ম্যানকে যেটা পাঠিয়েছি দেখো সুমিতা ম্যাডাম কি হবে
I think there is some connection problem.
No, here I am. Sorry.
Hi. Yes. Okay. You continue.
Yes. No, it's because there is a construction in my house, so they are with a hammer. Sorry.
It's okay.
So okay. That situation was related with the landslides, but after, obviously, in the lowlands next to Nicaragua border, we had a lot of big floods that affected, very interestingly, previous regions that had rice, pineapple, and pastures. As you can see here, we used, in this case, perhaps many of you use satellite images, where we use radar images in this one, to know where it was the affected areas for the floods. This is the volcano I was mentioning you. It was the impacted region by debris flows, and here are related, but with floods. Look, the helicopter flight images. You see the impacted area close to Bijagua, debris flows, and look, a lot of the material of the debris wood or large wood, the trunks along the river. After that, you see less trunks, but you see a lot of floods and large floods in the extent flatlands. Look, in rice fields that previously, many years ago, they were wetlands, and pineapple fields that are growing during the last decade in this area. It's northern Costa Rica, close to the border with Nicaragua. 1 year after, Tropical Storm Nate impacted as well Costa Rica, and 11 people died in Costa Rica. Most of the affected areas in Costa Rica are bridges and roads. This happened in the same area, the same region, during that event 4 years ago. For this event, I tried to implement the dendrogeomorphic approach, and in a geomorphology paper published last year, we used 3 different ridges. These ridges flied with the drone, and we took the different height of the flood, as you can see here. The methodology of this is you go to the scars, or this is the paleo stage indicator, as PSI. You model the water depth, and you try to find the right water depth, and then you can say that was the peak flow discharge of that specific area. So you, in the program, you use a 2D hydraulic model. You can use many, EGRAS, Flow2D, or EVER, and then you are flowing. You say 150 meters, 200 meters, 300 meters, until you reach the mean square error, the less, then you can create the peak flow discharge for that area. We make that for these 3 ridges, And then the results you have are, you have the peak discharge, you have the water depth, you have the velocity in this ridge, and you have the flood number. The flood number is related with the rugosity, the roughness of the surface of the river. And you use the different trees heights to know the deviation, the total deviation. So you have deviation from 2 meters to less than 2 meters to more than 2 meters. So you have to look where are the most or the less uncertain samples in your model. After that, I realized that depending of the geomorphic position of your tree, of your sample, you have less error. So I tried to model that as well. And with a statistical model, I realized that the cut banks have less mean square error than, for example, the point bars and the straight channels. And this was consistent with the flood number. So basically, we have reliability to use the scar-based flood reconstructions in the tropics, as well in temperate environments. The geomorphic location of the sample trees are important to reduce the uncertainty, and the risk implications to reconstruct these flows, these peak flows, can be used to determine the flood zonation. That is very important in terms of risk reduction. Very recently, like 1 week ago, another paper was published in Geomorphology, but related to a regional approach to make a flood analysis in a regional aspect, integrated a regional flood model and a dendrogeomorphic model. In this case, we had seven sample sites and 8 hydrological stations from the government. They had information from 1960 to 2017, and we can reconstruct the return period for these areas. So we saw that the return period of these areas. You get the presentation. No.
Okay.
Let me see. Now you're seeing?
No.
No. Let me see.
Mm-hmm.
Something happened here. Let me see. Just a minute.
Mm-hmm.
I'm going again. Now you're seeing you. Now?
No, Adolfo. Yes, it has come.
Yes. Okay. Sorry. Then, so basically, with this, so I used those seven reaches to reconstruct the flood in 2017. So with that one and the historical floods, I could reconstruct the discharge and the return period for this area. So I had many little watersheds or catchments. For example, the smaller one was 129 square kilometers, and I could know that to have a return period of 500 cubic meter per second, I need around 80 years to reconstruct less 50 years. Every 50 years, I have a flood of 500 cubic meters. But in the case of this one, that is the output of the whole basin, that is 5,400 meters, I need around 100 years to have an output of around 13,000 cubic meters. You have those flow, so these big flows in India and in many big rivers. But in terms of tropical rivers, this is very interesting because we don't have enough data. We lack of a lot of information. So to make these regional approaches can be very interesting and very useful to make decisions of the territory. Also, using there is a very good tool called hydrogeomorphic floodplain from Nardi and other Italian authors that they automatically delineate all the floodplains of your basin, and inside this basin I had the return period of every 10 years. That is as you saw, the impact of the tropical cyclones in Costa Rica. So I multiplied that with the topographic wetness index inside, and I calculated the hazard of flood in this area. So I had the hazard, I had the exposure as well. The exposure was calculated using United Nations human data. Is 90 per 90 meters of resolution of the exposition of population, the concentration of population using satellite images. This is very good tool. The vulnerability was calculated with the social developing index of Costa Rica. The less developed are indigenous and rural towns in the south of this basin that is next to Panama. And finally, I could calculate the risk, the interaction of the previous three variables, and then I could see where the flood risk is higher, and then I could give this to the authorities so they could take actions in these areas. 1 year ago, I was finishing this paper, and this hurricane happened 1 year ago, the Hurricane Eta. Hurricane Eta produces even 600 millimeters of rain in 2 days. It's a lot of rain. And about 6,600 families were affected. A lot of people in shelters. $15 million only in Costa Rica, and this $15 million only in road infrastructure. And look, for example, the high risk points that I calculated using dendrogeomorphic application and hydrological applications, and you can see in the field what happened. Look, this is basins in mountains affected by the hurricane. In the outlets of this basin, for example, you can see the impact of the flood in just a few minutes, just in a matter of hours. Then in mountain areas here next, very close to the border with Panama, the same, in areas that normally are not affected. And in the output of the basin, that is the start of a big wetland that I showed you in the beginning of the presentation, around 13,000 cubic meters per second during this event. So basically, what I have to show you, is that these models works, and you can see that these models can be used in different countries with a scarcity of data, because data many times in Costa Rica you don't have it, and you have to use what you have, and you have to create your own models. This was a model that basically I created, and it was implemented. Sorry. So this is my presentation. I hope you like it, and I'm open to questions. This is my email around here, and you can search me in Google Scholar or in ResearchGate for more information. Send me your invitations, and I will be more too open to collaborate with you anywhere you are. Thank you.
Question answer. Yes. Well, thank you, Adolfo. Thank you very much. And I will just put your email ID here. Here also, I'll put your email ID in the chat box so that everybody can get that. You may copy the email ID, and you may ask any question, any query. If you want to collaborate with him, you can directly ask. You can directly send him the email. Now it's the time for discussion, and I request all of you to have any. If you have any query, please ask him directly. Yes, he has also given the ResearchGate profile ID. Shurajit, why don't you ask? Why don't
we have one question here by
Shurajit Kundu. Yes, Shurajit, you can ask directly if you don't have any problem with your setup.
he asked what are the tree identification for bimodal annual rainfall condition in your research area. Is there any significant differences in annual rain growth for single raining or bimodal rainy seasons? Surajit, this depends in a huge manner if the tree species you have mark annual tree rings. If not, you will have problems. You need, first of all, you need to assess, you need to prove that your tree species mark tree rings. If they mark tree rings, you can after identify in which month is the early wood and when is the late wood. And then when you have early and late wood, you complete a year, you complete the cycle. And then you can say, okay, I took the samples at the end, for example, of the rainy season. When the dry season is starting, is the late wood. So it's a new year starting. So after that, you can make the analysis. Actually, if you look in my profile, there is one paper related to this in Dendrochronologia. I can send it to you in a moment.
Okay, then anyone else? Anyone from the tropics? Anyone from the other areas in the world? Please go ahead and ask the question, please.
Sorry, no, this one.
Yes.
This one.
Thanks a lot.
This one, Surajit, is the one. Sorry.
So Surajit, Adolfo has shared one of his papers through this particular link. You can directly go to his ResearchGate profile and search through all the papers. And if the full version is not there, you can directly ask him. He will send. So we are waiting. We are waiting for the questions. Adolfo is ready to accept the questions. Please, if you have any query, please ask. There is a feedback.
Thank you very much for the nice presentation. Actually, I'm working on the same area, but with interdisciplinary background. I have master in geology or in geomorphology and BH in geomatics engineering from University of Calgary. So I'm just wondering why you mentioned that association of landslide with volcanism or with volcano eruption is abnormal or something that I think this is normal to be happened, that landslide can be associated with seismic activity usually associated with volcanic eruption, or there is something different in Costa Rica?
No, not necessarily. Let's first understand that the volcanoes are basically made up of different layers, no? So they by nature, they are unstable. So when you have an earthquake, those areas are more unstable, and basically many times you have seismic landslides. But after that, if you have rains, especially in the tropics, you will have landslide, but this is a fact. So if you study the coupled dynamic related to the earthquake and after the rain, or it could be the opposite. You can have a lot of rain and a few months later you have an earthquake, you will have triggered landslides.
Okay, thank you. Also, I have another question regarding the risk map for flash flood. I didn't get all the information. You used some morphometric factors or some hydrologic models to have the flood map. Can I have some more information about the risk map you did on the coastal wadis or in coastal channel?
Basically, I created a flood hazard index first. No, it was using a regional flood analysis plus the dendrogeomorphic analysis. When I had the return period is for 1 per 1 square kilometer. So with that information and multiply it to the topographic wetness index inside only the hydrogeomorphic floodplain. No, so then I have the hazard. The exposure, I use another variable, the socioeconomic variable, and the vulnerability socioeconomic variable. So I multiply them, and basically I exponentiate them to 0.33% because there's three variables. So I multiply them, and then I have the risk.
Okay, thank you for the nice presentation and nice work. Thank you.
Thank you, Mohammed. I will put you this last example in the chat, and you can download the paper as well.
Yeah, I'm trying to download via ResearchGate, but something happened. Yeah, I'm trying. Yeah.
Okay, is that one I just put in the chat? You can use it.
Okay, thank you.
You're welcome.
Thank you, Mohammed, once again. So we have some time left for a couple of more questions. Yes, I can hear some voices now.
Shantunda, shall I ask one question?
Yeah. Sure. Why not?
Yeah. Can you hear my voice?
Yes, absolutely. It's coming.
Yeah. It's a great presentation again. My question is directly like, how should we identify the species for species of the trees I meant, like for dendrochronological analysis for knowing the climate in the past?
First of all, you have to check the different books or research indicating which species in your area of study mark tree rings annually, because many species do not mark tree rings in the tropics. Most of the studies, most of the species in the tropics do not mark tree rings. Normally are Pinus or the Pinacea family, or it could be, it depends on the region. So you have to check first, and depends of what.
So like if we are working in the mountain areas.
In India, there is a study of the potential species.
Suppose if we are Suppose if we are working in the mountain regions, we are having very limited trees in the mountain. As we go up, the trees are less and less due to the local geomorphology of the mountain environment. So how do we identify the dendrochronological species, like means species of the trees for dendrochronological analysis for knowing the climate in the past?
You have to start, the first step is check
like pines or
exactly. But first, the idea here is first you have to search previous studies and you identify the species. Second, if not, you go to the field and bring samples and you check them if they mark tree rings. Is the second option.
Okay.
Those are the two options you have.
Okay.
And remember that dendrochronology, you have two options. You can work in macroscopical approach, that you just polish the samples and you can see the rings. No, that's the most easy one. But the most difficult one, and you need a better equipment, is the microscopical or wood anatomy. So you will need to take little samples that are 0.25 millimeters. Imagine that. And those samples, you have to stain them. You have to put different colors, alcohols, and then you have to look in the microscope and you have to make your chronology. It's very difficult and take a lot of time.
Okay, thank you very much.
Arindam, just one more, just one thing, that this tree ring analysis is is not very alien in this part of the world. I mean, in the Indian subcontinent. And as I can remember that the river Brahmaputra, which is one of the largest river in the world, the tree ring data of Brahmaputra is actually available for the entire 19th century. You can go through different works related to that. You can search to the internet and you can get it. So earlier it was not possible to calculate the discharge. Obviously, the stations were not there, and it is actually the only way to reconstruct the data of earlier times for that particular river or any river of that shape. So it has tree ring data is also used in this part of the world. Okay, and
Okay.
thank you.
Okay.
And Adolfo, there is another query.
Thank you so much, Shantan Dal.
Yes, I think there is another query. Modibbo Babagna Carey. He wrote, please, can you give me a hint on how to assess the risk of sand dunes advancement over settlements using GIS and remote sensing? I have an MSc in GIS and I have interest to pursue PhD in environmental geomorphology. I'm from Nigeria.
Hi, Modibo. Well, I don't I don't work how to call this aeolian geomorphology. I've never worked in aeolian geomorphology, but I think the method is kind of the same. Basically, in this case, what you can use, if you want very good resolution, you can use only Sentinel images from 2014 to now, and you can see the movement of the dunes in the last 7 years, and then you can make let's say you can make a potential problem that you can diminish in the future if you make how they are growing, and then you can reduce that. Sayantang and Kapil, and Arindam. No, Kapil wasn't there, but Arindam was there. You remember that the study we saw in Java?
Java, yes.
In Indonesia, you remember?
Yeah.
So they used satellite images, and they were showing how the dunes were moving towards the towns, but you have to do that. But after that, you have to make a kind of assessment of what the people have to do. They have to move from there. No, perhaps they can, but perhaps they adapted all the crops in there. Though they continue living there, but they were cropping different things or making different activities. So you have also not only to say, okay, there is a problem, the dunes are moving, but okay, how you manage the territory with the people in there. That's the most important thing. Never forget that.
Okay. I think you have got the answer, Modibbo. So time for one last question. Okay, Modibbo is saying hi. Yes. Hello, Modibbo. Okay. I think, yes. I think we can close this session now. Many thanks, Adolfo. Many thanks for accepting my request. And yes, it is pretty early in the morning in Costa Rica, but in spite of that, you able to join us. So I'm pretty thankful for that. We are pretty thankful to you for that. So once again, yes, obviously we'll meet again. And maybe some you have talked about the young geomorphologist group you want to establish in Costa Rica. Maybe we Indians, we can also participate in the sessions if you organize anything in Costa Rica through this medium.
Thank you very much. Thank you very much. And have a nice evening. Have a nice afternoon in
yes.
Africa and Europe.
Yes. And yes, another, okay, very fruitful session. So comments are being poured in. Then Diamentia Griva, exceptional presentation. Thank you, sir. Okay, so comments are being poured in. So thank you, Adolfo, once again. So we'll be moving now to the valedictory session, which is going to be the last session for this particular event. Okay. So with this, the formal sessions are ended here. Now I am formally now starting the valedictory session, and yes, we have two special guests with us in the valedictory session. I'd like to welcome, on behalf of this forum, I would like to welcome Dr. Kalyan Rudra, who is the chairman of the Pollution Control Board in the state of West Bengal, India, and he's a very famous river scientist. And you can see many of his papers in the internet, in the web domain. And we have with us the director of Human Resource Development Center of the University of Calcutta, Professor Lakshmi Narayan Satpathy. He was previously also associated with the Geography Department of University of Calcutta as the professor. So I'd like to welcome you both, and we'll have a couple of words from you, obviously. But before that, I'd just like to present something. I'd like to present my screen. Just a short presentation. Yes, I can see the comments also. So I'm just presenting the screen. Just a moment. So this time, this particular event. What? Yes, it has come. Yes. This particular event, we actually invited applications from all over the world, and it actually, it is actually possible because of this online medium, this online version of the program. So previously, the first edition of this particular event was held in Kolkata, and there were 70 participants. But this time we have 240 participants, including the committee members, including the program committee members. Now, obviously, the most number of participants came from India, and especially from West Bengal, which is traditionally a very strong zone for the geomorphologists. Now, from West Bengal, there were 120 registered participants, and you can see the state level participants outside West Bengal are mostly from Assam, Uttar Pradesh, and then Jammu and Kashmir, Kerala, so New Delhi, Uttarakhand, Tamil Nadu. So all over the India, the participants have come, and yes, obviously the country level. If we see the country level participants from outside India, yes, we have received applications from all the continents except obviously from Antarctica. There was no one, but starting with Australia. And Australia was there. Then even from the Latin America, we have so many participants. The maximum number of registered participants came from Nigeria. So 11 participants were there. Apart from that, Cameroon, and it was followed by Poland. Then we have 4 registered participants from Brazil. And one thing I'd like to share, that from every hemisphere, participants have registered, not only from every continent. And as far as, if we consider the farness of the participants, where their residents are, even the last province, if we consider the Earth landmasses before Antarctica, so the last province in Argentina, Tierra del Fuego, one participant has registered from there. So our event, in terms of the number of registered participants, I can say is quite successful. So obviously, it's quite an achievement for us, and many people have joined from all over the world. And we had just a moment, let me stop the presentation. Yes, we have many presentations, and we tried to make the topics as much diverse as possible. So yesterday, there were many presentations on the fluvial geomorphology, on the glacial landscape also. And then we had presentations on drone and geochronology. And this time we have had 2 presentations on the oceanic landscape and coastal landscapes. Then Adolfo talked about this tropical phenomenons, different tropical phenomenons. And we had Fran talking about this drone survey, UAV surveys. So yes, different types of presentations, and obviously we will receive feedbacks regarding it, positive and negative both, after this session is over. And yes, now I would like to call on Dr. Kalyan Rudra. Sir, if you are there, please open the screen. Sir, you're muted. You are muted, sir.
Is it audible?
Yes, it is. It is audible.
Yeah. Thank you, Sayantan. And I can also see my old friend Professor Sunil Kumar De here. Sunil, how are you?
I am fine, Kolana. I am fine.
You are now in Shillong or somewhere here?
Yes, in Shillong.
Yes. And I can also see my friend Professor Lakshminaran Shanpati and some of the young geomorphologists. At the outset, I must admit that when I was requested by Sayantan to be here in the valedictory session, I was little confused. I thought that what Chairman Pollution Control Board dealing with the air quality on the eve of Diwali and being bombarded by so many court cases, starting from Supreme Court to Kolkata High Court, can do what kind of justice to the young geomorphologist. Initially, long back in 1975, I came out of the Calcutta University with a specialization in fluvial geomorphology. That I admit, at that point of time, we had been taught by Professor Monotosh Bandyopadhyay, Subhash Ranjan Basu, and many other leading geomorphologists. Subsequently, what I did is on the erosion of the Ganga. But at this valedictory session, Sayantan, I would like to say that this is a very important branch of geography, what I call geomorphology, which has not given proper heed it deserves by the planners. I will just cite an example. I had been working on the changing course of the Ganga from Rajmahal down to Bangladesh. The lateral oscillation from multidated maps and my fieldwork, etc., etc. I clearly find that the Ganga has its own meander belt, and a scientific land use plan based on this needs to be designed. But neither the Planning Commission nor the State Planning Board invited any geomorphologist to do the needful. So this is a subject which has immense importance on planning processes. I'm very unfortunate that I could not follow all the presentation because I was too busy in my office for the last 2 days, and it continues to be. But I would request you to assert yourselves, my dear young friends. And I also want to request you to take a new approach. I understand that geomorphologists nowadays relies too much on remote sensing GIS, and they have a close linkage with the geology. But some other subjects which we generally deny is like archaeology, like the travelogue, like the medieval and ancient classical texts. They also give some hints to geomorphology. Say, when I was trying to explore the medieval or old perennial channels of the Bengal Delta, I was trying to find out the best navigational route during the early 16th or 15th century. And that is described in many classical texts and medieval literatures. And if you go to the travelogues like that of the Ptolemy or Periplus and many other travelers who came to this part of the country, they have given a very important clue. If you want to really identify the coastline, say, just to be brief and precise, I was working on the two ancient port towns of Bengal. One is Tamralipto, which is supposed to be the oldest port town of the Bengal Delta. Other is Chandraketugor. If you nowadays go to these two places, in all classical texts, it is described that Ganga is flowing along the bank of the Tamralipto. But nowadays, you will find it is located, archaeological ruins was explored from a bank of a river which is tributary to the Ganga. If you go to the Chandraketugor, which has been described as an important port of the Bengal in the early first millennium era, you will find that no rivers are there. The Vidyadhari has gone dry, the Jamuna has gone dry, the Padma has gone dry. So these are the areas where archaeological ruins can help you. So what I like to be very precise, that geomorphology is an interdisciplinary science. And you will have to embrace many more science which can render you the necessary information and inputs. My dear young friends, I would request you to break the barrier of the so-called geography and go beyond that and embrace many other subjects. I was very attentively listening about this last presentation, the dendrochronology, about the dendrochronology. That is a hugely important issue. So we'll have to find out a new curriculum of geomorphology where we can embrace many other allied sciences to find out or formulate a new geomorphology which will help the society. Most important is how much you can contribute to the societal planning. If you don't do so, if you can't do so, your subject will not be recognized as a subject. You will have to understand that you will have to involve in the planning processes. So you will have to do something which is relevant to the society. So with these few words, I think I should stop here. I congratulate all the young geomorphologists who have contributed many important papers. I will try to look into it, and if Sayantan helps me, I will see, and I will rather enrich myself reading those papers which have been presented here. Thank you all for your presentation.
Thank you so much, sir. Thank you so much for joining in spite of your very busy schedule. Thank you so much, sir. And now I'd like to ask the director of the Human Resource HRDC University of Calcutta, Professor Shapati, to say a few words.
Thank you, Sayantan. And I'm really delighted to be part of this valedictory session. I must acknowledge the contribution of Professor Sunil Kumar De, because he was the person behind this Young Geomorphologists Forum. And this is a very good platform where the young geomorphologists, they are being trained. And they are also encouraged to think not only in the way of the traditional geomorphology, but also the modern geomorphology with all its techniques and the tools. But we have to remember that for any success in the field of geomorphology, we have to go to the field. Because in these days, the micro level works are being done, which cannot be done using only the tools which are available in these days, maybe the sophisticated data set, remote sensing data, whatever may be the spatial or the other resolutions. Because the human interventions at the very local level, those are very, very significant. And more importantly, whenever we are doing something scientific research, it has to be interdisciplinary first, because it is not the domain, all the catastrophes, the hazards, the geomorphological extreme events, those are occurring in these days. How can we find the solutions? And there it is not the domain of the geographers or the geologists, the engineers. So everyone has to discuss. And there must have the dialogues which can be understood by everyone. But what is the purpose? That is most important. It is the how we can live in a better way. How our planet Earth can be given its due care so that it remains livable. Another important issue is that in these days, we are putting much emphasis on our API scores by publishing in scientific journals. But it is also very important that why don't we write in the popular media? Because otherwise what is happening, all the scientific rigorous researches are remaining in the libraries. They are not being considered at all by the policymakers. And, our leaders, the political leaderships and the administrators who have the power to implement, unless they have the right kind of information which can be shared by the scientific community, then the same thing will happen year after year. And then flood will become an issue of whether it is a natural event or a man-made issue. So the debate will continue, whatever publications are coming in the scientific journals. Then another issue is that we have enough study, and still we are doing many studies in the field of paleoclimatic or paleogeomorphological, and various models are being prepared, and they are mainly working on hindcasting method that we call backtesting. But backtesting may not be very good, very viable for future prognostication. So we have to validate it on the basis of various types of scenarios. Like say IPCC, they have developed various types of scenario representative concentration pathways. Similarly, for any kind of prognostication in flood events or many other hazard events, we have to look into that what kind of scenario is going to develop for the future. And then various perspective documents can be prepared for say 20 years, 30 years or 50 years, like say IPCC has done for the next century, that whether it will be 2 degrees Celsius or less than that, and the conference of the parties, they are doing their business, whether it will be meaningful or like that. So I think we, the geomorphologists, have a very big role to play for the society, not only by publishing good research, but also helping the media and also our policymakers by giving good input, scientific input to the problems so that they can be solved. And various adaptive and mitigative measures can be taken up. So with these words, I again congratulate Santon and his team for successfully organizing this beautiful workshop. Thank you very much.
Thank you very much, sir, for your kind words. And yeah, let me tell you one thing. Let me tell all of you one thing. It's not, it is not some kind of disappointment, but still, had it been a offline event, the situation, I mean, the executions might be different. Obviously, there would have been some one-to-one interactions, would have been some field works. So these things are needed because we are all working working with geomorphology, and geomorphology always deals with the physical landscape. So without that, I think every workshop, any kind of workshop like this is incomplete. So unfortunately, we couldn't do it. It is some things are beyond our hand. So now this time I will ask everyone to share their feedbacks. Shubhendu is also there, our co-convener, and Kapil is also there. So yes, almost I can see the other members of our event team is also there. So I will ask everyone to share their feedbacks. We have 5 to 10 minutes before closing our sessions. Yes, Joyesh, you can, instead of writing it here, you can open the camera and you can share your feedback. Anyone from India? Anyone from outside India? I think Mohammed Shoki from Canada. I think it must be morning.
Yes, true. It's 8:20 in Calgary now. 8:20 a.m.
You are from Calgary, okay?
Yep.
Okay. So, how did you like the program?
Actually, not only now. Long time ago, I see that the Indian School of Geomorphology is rich. Okay. School, they have different experience. Actually, they work in different environment, especially the fluvial geomorphology. Starting even of the real work of geomorphometry, started with Indian scholar. Yes. All over the world. The geomorphometry work, the real work, the application. So it's really a nice meeting, and I wish that we can have a regular meeting or even a group that we can share and collaborate together. I think this would be very good if it's possible. Yeah.
Definitely, Mohammed. Then we have, I think, Aniska. Aniska was there right from the informal meeting. So Aniska, please, could you please open the video and share your feedback, please? You have put some message on the chat box also. Yes, Aniska, please carry on.
Hello, I am from the University of Warsaw. Thank you very much. I really like all of the presentation. They were very interesting, and this event being online has also the advantages, because I think that a lot of us will be not here if it will be in India. So I'm not sorry that it was in this form.
Okay, thank you, Aniska. Then
Thank you.
Anyone else from India? I can see Zofia. Zofia, if you are there, Zofia.
Hi, yes, I'm here. I'm just not going to show myself because I'm really, not well prepared for that. Yes, but I'm also from Poland. Yeah.
You are from Poland?
Yes, I'm from Poland too. I'm from I'm a PhD student at the University of Szczecin.
Okay.
Yeah, and I'm also very glad for having those lectures, even though I had to wake up quite early. Maybe not today, but yesterday. That was Actually,
we adjusted the timings because 3 of our speakers are from Europe. So,
yeah. Like today, it was much better, I need to admit. But thank you anyway. It was a really nice opportunity to attend and to listen to all of those things, especially because I'm just starting my journey with coastal topics. I've never been involved in this kind of things before. I was working on a forums, so that's a very new thing for me, and I'm really, really happy and very thankful for this opportunity. So thank you so much for organizing this meeting.
Thank you so much. And have some more feedbacks. Yes, Diamantia? No, she's not here.
Sid, this session I felt that is really useful, but I have one more suggestion. Though talks are it went bit lengthy, I think it is better to include more sections with some more case studies. That will, I think, it will create people more. They will create more attention.
Okay.
So this is my feedback.
No, definitely, I take that into consideration. But before that, yes, if there were more case studies, that would have been helpful. But still, many people. I mean, if it was case study based, so suppose someone is working in the European environment or Latin American environment, the problem is it might have been a bit, people might not have correlate with those things, because many of the places are unknown to them, because most of the participants are from India. Okay, like Fran from Croatia, he delivered his lecture on this, UAV. So it was a generalized topic. So these kind of technologies can be applicable anywhere in the world. So I deliberately made some lectures which are concentrating on general topics, not myself, our team, so that people can correlate. There are some case study based, like you have seen this Costa Rica.
One more thing, like if you are included some case studies from Himalaya. See, sir, everyone knows about Himalaya, and everyone are very keen to understand about Himalaya.
For that, we had our last day's lecture delivered by Professor Sharma, although it was not case study based.
Yes, sir.
But still, many of his works you saw many of his works over there or on that particular presentation. You can ask him. I already gave the phone number. Email ID. You can directly ask him for the papers. Yes, Anna.
Sir, actually, the thing is, this kind of expert opinion will help us to interpret some landscape.
Definitely.
So, like how they are interpreting, actually, that will give us also, okay, we have to interpret in this way. So that is actually this kind of case study will help us. So this is my.
Thank you, Thank you so much. Yes, Aniska. You.
I would like to add a suggestion for future, because I hope that the next time it will be possible to make the event like this in the normal stational way. But why not make it like in hybrid way? So it will be the possibility for
that
people.
thing is already in our mind. Yes, a hybrid mode, blended mode system is possible. Thank you, Aneska.
Thank you.
Anyone else, please share your opinion. Anyone from Africa? Oluwatosin, yesterday you tried to say something. Asma Aichi from Morocco. There is a representative from Morocco. Then yes, Oluwatosin, go ahead. Yes, you raised your hand. Why don't you unmute yourself and share your opinion? There is some problem with her voice, maybe, or some problem with her connection, maybe. Okay, and then voice is very faint. Yes. Okay, Oluwatosin, you can put your comments on the chat box. Anyone from India? Devashree Sinha.
Yes, Shayantan, just... Am I audible?
Yes, absolutely.
Okay. Yeah, it's actually very difficult to put into words or, give a summary of the experience over these 2 days. But I think, what I would like to say is that had this been a physical session, undoubtedly, yes, it would have had some advantages. And it would have also had its challenges, but I think also equally it's very difficult to work out the logistics of a 2-day online session, which I think has been done extremely well. We've seen a great variety in the presentations. We've had the fluvial glacial aspects covered. We've seen mapping. We've also, I think, have had a good look at the necessary theoretical background and conceptual framework that is also required. And side by side, we've also had a good training regarding the latest available technology as far as mapping is concerned. So I think I would like to say that, yes, the 2 days have been long and intensive, but I at least personally feel that as young geomorphologists, we've had a very good exposure. And if it has been long, I mean, if it's called a training session, that is precisely what is expected over these 2 days. So yes, I would definitely like to congratulate the entire organizing committee, because this by no means would have been an easy task. And I think I would agree with, I think it's Aneska who said that she's quite happy because, yes, we wouldn't have seen such an overwhelming international response had it been a physical session. I think we would have lost out on that aspect. So that has been entirely possible because it was in the virtual mode. So yes, from my end, thank you to the entire organizing committee for giving us these 2 days.
Thank you so much, Devashree and Warnas. I think we still have one of our speakers for today with us, Vittoria. Vittoria, if you can share your opinion.
Yes. Yes, I was just writing in the chat. I'm very glad to have participated in this meeting. It was a pleasure listening also other presentation of the other participants. They were of extremely high level, really, and they were, I think, general enough to be applicable also in other area. For example, the presentation of Adolfo talk also about exposure vulnerability in another area, but the same concept as we applied in the Maltese archipelago. So really, and I enjoyed the presentation of the Greek colleague. Her enthusiasm was contagious, and was a very, very nice meeting. I would like to thank a lot Sayantan for your effort, and of your team. Thank you.
Thank you, Victoria. Thank you so much. Sunil sir, will you say something as the vice president of one of the vice presidents of IAG? Please share some words.
I talked so much during the inaugural function that what else I will say, but I am happy that our mission of forming this geomorphology group under the banner of Indian Institute of Geomorphologists, and it is approved by the IAG, has now become mature. And I am really glad that last 2 days, although I was logged in many occasions, I was not present sometimes because of some departmental aspects. But the way you have organized, I am overwhelmed. And a big thanks to all of you. The three musketeers were sitting there in front. And I really thank Sayantan, Shubhendu and Kapil. And I hope that this will continue for a long time. And I am also happy that our next generation is ready to take over the charge. Thank you very much again.
Thank you, sir. Thank you.
Thank you so much, sir. Thank you so much. And
not only that, you have given this international flavor of this young geomorphologist session, intensive workshop. It is a great thing. So I would suggest you to write an exhaustive report on this issue, because next month there is IGI conference. You will have to present there. Moreover, I'll have to submit the report to the IAG.
Okay, sir. Okay, definitely, sir.
Thank you very much. Good night.
Yes, good night. And before ending the session with the vote of thanks to be presented by the organizing secretary of this program, Dr. Kapil Ghosh, I'd like to inform you about the most important thing of this event, that is about the certificates. Yes, many queries we are receiving right now about the certificates. So don't worry about the certificates. We'll be distributing the certificates by the end of this week. I think all of you can get by the end of this week via email. It's via email only, and you don't worry about that. And we'll also send the certificates to our speakers and our resource persons. So you don't have to worry about certificates. Okay. And if you want to share any feedback, till now we didn't, decide about creating any Google Meet link. Google form related to this feedback. But if we share something, please once again share your opinions about this program. I know nothing is perfect. Our program is also not perfect, but still, in spite of so many roadblocks, we have actually put this thing together within, within 7 to 10 days. And the response has been overwhelming. Especially, we didn't expect so many participants from abroad, from outside India. So with this, I'll leave this space for Dr. Kapil Ghosh, who is the organizing secretary of this program, and he will present the vote of thanks. Thank you, everyone. Thank you. Good night from India. Kapil, it's over to you.
Okay, thank you, Shantanda. Am I audible to all? Yes.
Yes.
Okay, thank you. Very good evening, or good afternoon, or good morning, those who are living in different part of the world. I feel extremely honored to get the opportunity to propose the vote of thanks. On behalf of the organizing committee of the second edition of the intensive training program, it is really great opportunity for us to welcome all of you. The forum would like to thank the International Association of Geomorphologists for supporting us with their auspicious. We are very much thankful to the Indian Institute of Geomorphologists, IGI, Allahabad, for their continuous support and their encouragement and providing us this opportunity to host the event for the second time. On behalf of the organizing committee, I convey my regards and heartfelt thanks to the patrons of this event Professor Sunanda Bandyopadhyay, Professor Sunil Kumar De, Professor Sudhakar Pardesi, and Professor A.R. Siddiqui for their immense help to make this event successful. In this regard, I also offered my heartfelt thanks to the President of IGI, Professor Devidat Chanial, for gracing the inaugural session yesterday morning. I'm thankful to all the speakers of this event, Professor Kale, Professor Sharma, Professor Basu, Dr. Bandyopadhyay, Dr. Victoria, Dr. Fran, Dr. Evie, and our friends Adolfo for kindly accepting our invitation and gracing the events. We are extremely grateful to you, all of you, for accepting our invitation with the very short time and share your knowledge and ideas and your excellent presentation. I, on behalf of the entire organizing team, would like to thank Dr. Kollan Rudra, Chairman, West Bengal Pollution Control Board, who gave his vital time from his busy schedule to grace the valedictory session. We are also thankful to Professor Ellen Shatpathy, Director of HRDC, University of Calcutta, for kindly accepting our invitation and gracing the valedictory session. I sincerely thank the convener of this year training program, Dr. Shantan Das, and co-convener Dr. Shubhendu Rai, and our organizing committee members, Dr. Arindam Sarkar, Dr. Annesha Haldar, Ms. Soheli Bhattacharjee, Pritam Shatra, and Abhijit Das, and Sajal Mandal, who are the main instrumental to make the event happen. And obviously, Shayani Mandal. Without their efforts, this event would not have seen the daylight. My sincere thanks also goes to all the participants from India and abroad who have been connected virtually through the Google Meet or YouTube link for last 2 days and who have shown patience and listened to all the speakers in last 2 days. I'm sure that we'll meet again in physically and definitely, as suggested by some other young geomorphologists, will try to make it in blended mode in next year training program that we could meet virtually or physically. So thank you all again. Good night.
Okay. Okay. So once again, I'm here. This space is now for yours. You can use the chat box to chat with each other for different purposes, and obviously for academic purposes, not for different purposes. So I'll leave this space with you. You can carry on chatting for half an hour, and then we'll close it out. Okay.
Okay, I'm leaving. Good night.
Okay. Sorry.
Big congratulations to all of you.
Thank you. Thank you, sir.
Thank you.
Yes, sir.
তুমি ওইটা আমাদের যে হোয়াটসঅ্যাপ গ্রুপটা আছে সেই ইনফরমেশনটা দিও এবং জয়েন করে দিও সবাই এটা একটু অ্যানাউন্স করো
আগের বছর হোয়াটসঅ্যাপ গ্রুপ ছিল okay then you carry on for another half an hour. We are leaving. Okay, thank you Oletsi, thank you Carlota, thank you Dheeraj, thank you Zofia once again, thank you Tinku, thank you Rashmi, thank you Dennis, thank you Ghislaine, thank you Arindam, thank you Jiarul, thank you Oluwatswin, thank you Vandana, thank you Rupan, thank you Karthik, thank you Dipanita, thank you Achu, thank you Ram. Oh, thank you Dennis from Costa Rica. Thank you Mohammed once again.